inside, they try to see what is inside. Home screen, alarm, user.
Yeah.
Shutdown.
Shutdown and restart.
Oh, this is shutdown result. This screen is a start screen.
Yeah, the main screen.
So if I click start, I press start, then it goes to the main screen.
Yes.
Transfer is go to another HMI.
No, transfer is ready for transfer. Ready for upload, ready for transfer.
So
but this HMI is still okay. But the previous HMI, because yesterday when we download to here, we didn't put to transfer, right?
question. HMI has a historian storing function.
Yeah.
So you need a
history means you mean the
I mean the process data like
data.
for 3 days, 1 week.
You have USB, right? So you can start the USB, so the data will go to the USB.
Relate to the
According to what the program, which value you want to log.
like this WinCC, right? This WinCC, there are many convert and so on, right?
Yeah.
All also
All.
can use.
Yes.
Or as long as you have a HMI, you program it correctly, you can store the data in the USB until it's full.
Yes, USB or memory card also can.
Or I buy a very big one, it can store for like one month also can.
Can go up to how many values? Very big values.
Very big value. Because I used to heard they say, oh, this one cannot store for long, only 3 days, then you only whatever very short time.
Oh. But can more than 3 days can.
As long, but because you say the
Depends
limitation
on how
is
many
on
data,
the USB itself, right?
No, not USB. How many data you want to log?
How many data you want to
Yes. So how frequent and how many data?
Trending is part of
Trending.
Yeah, trending is part of the WinCC, right? So in the WinCC, we can program it to be next page show a trending.
Yeah, we do trending when we do the PID.
Okay.
You just remind me when we do PID, just remind me. Because when we do PID, of course we do trending, we want to see the temperature, right?
Yeah. Okay. Got it. Yeah.
Good.
Okay.
Okay. Now, first what we want to do, we want to do backup of the HMI.
Okay.
Okay, let's say yesterday I say right, if the HMI you backup, you cannot open the screen, right?
Okay.
Okay, let's see how. So this is the S7 project, right? Okay. This one you minimize this. So can minimize. Okay. So to back up the HMI is another software.
Okay.
Okay. But when you install TI portal, it will be installed together. Okay. Or if you install WinCC flexible, the older version, it will install together.
Okay.
Okay. So you search here. Here. You search here. SIMATIC ProSafe. Yep. This is the HMI backup software.
Okay.
Okay. Now,
Program also backup using this one. I mean the PLC.
no.
Okay.
PLC is just TI portal.
Just TL upload and download.
Yes, upload download can do. Or the old one, SIMATIC Manager, upload download can do.
Oh.
PLC. For HMI, if you want, so you create new project, can download. But if you want to backup, right, must use this.
Okay. So in future, anything crash or whatever backup here, I
Can restore.
download, reinstall. Okay.
Okay. So KTP400 basic PNIE, this is the IP address, right?
Yes.
Okay. So now the PLC, sorry, the HMI, right, is showing what?
The home start center.
The home, start,
Yeah.
transfer, everything.
Yes.
If this one is still okay, the old one you need to press transfer. Then only it can back up.
Okay.
The new one still okay, no problem. Go to backup. So complete backup with license. Okay, for click here. Save in your folder. Okay, HMI backup. Okay. Start backup.
This cable we use, this Ethernet cable
Yeah.
for industrial use, any specification? Like for example, it must be Cat5 or
Must be more than Cat 5.
more than Cat5, or there's a minimum.
Yeah,
Cat5,
because-
Cat6, whatever.
Yeah, Cat 5, Cat 6 okay lah. Because Cat 5, Cat 6, the depend is in the speed, right?
I don't know what is
The transmission, the Cat 5 and Cat 6 is depend on the transmission speed.
Okay.
Ah,
So as long as so usually people do the this wiring, cabling,
Yeah.
and everything.
standard
For-
they use Cat 5.
They always use Cat5 as standard.
Standard lah.
And then the color we say, let's say we say Profinet is a green color, right?
Yes, green color.
But what you call this, the connector,
yeah, the head lah.
the head, is slightly different design, right?
Yeah, it's bigger.
Bigger.
Yeah.
So that is a special kind of
Not a special kind. It's the same thing, but it's what? It's a Siemens one lah.
that is
Siemens
officially you buy from Siemens.
Yeah, Siemens connector or some other brand also they also sell.
What is the difference between that one and using this one?
Same thing.
Same thing. Just
But just
design
industrial
different.
standard because this one you see if you use sometimes mine all the tip is broken. You see?
So this is the connector is less reliable lah.
Yes.
But the green, the purple color is purely must buy from Siemens. That one is a
Yeah, that one also is just nothing. The what
Just nothing
cable
also.
inside the two cable only. Just two core only.
What you meant is a
Coffee bus.
coffee bar.
Coffee bus connector.
Connector.
Mm.
This is a this kind of connection. RJ232, right?
485.
415.
485.
485.
They use the protocol 485 protocol.
But the special thing about this,
Inside
it
they
has
have
a two side here.
yeah, because down you can connect to the PLC. On top you can connect. Can you see the other cable?
It's like you can connect multiple of this one.
No. Okay, for example, connect here. This one I connect already, right?
Yeah.
Now let's say I want to do some troubleshooting. Let's say this one also is connected to something. Okay, so this is the cable I can use for communication, laptop to my PLC.
Or in the past people use this one.
Yes.
Oh,
So
okay,
you can
okay.
connect this one here, then this one to your laptop.
This is for mainly is really
They
not
call
permanent
MPI
or
cable.
MPI cable.
Multi-point interface.
In the,
S7-1500, they use MPI.
in the past, this S300 people do like this.
Yes.
Nowadays people
Now
just.
all the internet.
Oh, okay. Actually, is this considered obsolete already, like outdated?
It's outdated now.
Coffee bus is considered outdated.
Yeah.
Got it. Got
Because
it.
now all using Profinet.
Oh, nobody uses proper cable anymore.
I mean for new project lah.
New project.
Yeah.
Okay, okay.
Old project of course. I mean old not old project. I mean the old which is still running on that.
Got it. Okay.
So this one will take some time.
Okay.
Like around 3 to 5 minutes. Okay. Because what happened is there's a problem with the Siemens HMI. You only can back up. So means you cannot edit, like you upload the PLC program, right? So after upload you can open the program, you can modify, right?
Yes.
You can do with that with the Siemens HMI.
So this backup meaning to say the only function you can do is you reinstall back to the HMI only.
Same model.
Same model.
Yes.
Okay.
Because in the backup file, you will have all the screens, the communication setting, HMI tag, the model, everything in the backup file.
Okay.
They call binary file, but backup file is inside the binary codes. So only can restore to this
Same model
same model.
HMI. Like this one breakdown, you install
Cannot do
the
anything
one.
because last time what happened, I did one project. They have this one, the ET200 PLC, okay? ET200S. Okay, so what happened is, both are same system, similar system. What happened, they created this like redundant, but it's not redundant. I mean, the PLC does not support redundant. Okay, it's like a file system. One is running means one can shut down.
Okay.
One is running means another one shut down. But it's totally two different IOs, everything.
But not redundant.
Not redundant. Redundant is two CPU controlling one system, right? I said got two systems.
Two different field devices.
Yes,
for
two
the-
different field devices. Okay.
Okay.
But you cannot shut down both at the same time. Only can shut down one at a time.
Okay.
Okay. So this one use EP177 the one that is similar to the HMI.
Yeah,
The
Siemens.
This Siemens.
Oh,
This
that is
HMI and this PLC they use.
Okay, okay.
This CPU. Okay. So what happened is their A, this one burn ready. Okay, so this one burn ready. So what happened? They asked me to back up from this and load to this. Then I said cannot because this is the what? B. This is A. Cannot do that. Okay. Then what happened is they say can I redesign this one? Okay. Because I need to know all the each button have a tagging, right? Okay. So I need to know all the addresses.
Right.
Okay. So what I did is I back up from this. I load to my HMI.
Okay.
Okay. Then this one I back up. I load to my PLC.
Okay.
Then I do the connection. Then one by one button I press. I check in the program which memory is on, which DB is on, all that.
Actually, so it works, right? So because they are identical software,
Yeah. Everything same. Only thing is, this one got 4 valve. This one only using 3 valve. That's all.
Oh, only one different IO.
Yeah. The rest is everything same.
Okay.
So what I did, I back up from this side. I put it into my HMI. I press one by one everything. I take note all the addresses. I redesign.
Okay.
Redesign the new project. Then I download because what happened? TP177A is burned ready. They already have a spare, but the same model. So what I tell them, okay, I have TP177B. I back up from this. I put inside that. Then we exchange.
Yeah.
Then they say no.
Why?
Because it's already in the system. This model, so they must use that model only.
Oh, this two is a different model, A and B.
Yeah.
Oh. A and B is a different model.
Different model, still different model. So back up from here, I redesign everything. Then they install a new one. I just go and download.
Okay.
So now I have the project file. Right, because I redesigned one.
Yes.
Okay. So the project file is what I did is I save this project file into 2 files. One is TP177B. One is because the project file I can change the model one.
Right.
I can click here. Then later on I can save as this version.
Okay. So you back up from this one, but actually you have to recreate a new file.
Yes, recreate. Then I keep this file. Then I download to the other one. Then later on, after 2-3 years, they call me. They want to change some description inside here and also inside here. So can no problem because I already had the file.
Interestingly, after a project, you hand over to your client. The project file you must give to them, right?
Yeah,
so
but some people they don't ask. So what happened? The machine makers they just keep the file. So in future you ask the file, then you charge for them.
But normally, so hand over
hand over because the thing is sometimes it's not in your agreement.
Not in agreement. Yeah, makes sense.
The program backups, everything not in the agreement.
Right.
So they just ignore. So in the future, like after 5 years, then let's say your company already have a automation engineer where he can do some programming. So you request for the file, then you call the guy to send the file. They say you pay extra.
Right.
That one also happen.
Yes, it makes sense also.
That's why I will tell my participants. Okay, of course, before this, you are not aware of this. These programs, these files, all very important.
Right.
Mostly because whenever you buy a machine, your company will have electrical guys, mechanical guys. So electrical guys, for them most important is a wiring diagram, machine layout, everything. Okay. For mechanical guys, the mechanical design, mechanical parts, everything. So for these 2 guys, they only need these 2. Maybe the process guys, they need the process flow, everything. But in your company, don't have automation engineer. So who will request for the program? Nobody. Right. So,
even the request also nobody can do anything.
So nobody can do anything.
Yeah.
So they're not aware of this. Okay. You come, they do the program, everything. Okay. Then in the future you have something, so you want to do some additional programming. So when you call them, it's very expensive. So you already have an internal engineer, right? And you want to do some additional programming, then you request for the password. Sometimes they put password also. Password or something. Because PLC is still okay because still can be backup. No problem.
Right.
You don't need the project file.
Right.
Only Siemens HMI you need the file. Other HMIs also you don't need the link. Because you can just backup.
Yes.
Backup and can open the screen, can do some modification and everything.
Okay. Yeah. Got it.
So I tell my participant whenever you buy a new project, you always put this in your agreement. Let's say
You always see this kind of condition. I mean, particularly let's say probably big vendor like they have a lot of market have a lot of vendor, even like asasmy whatever. Probably and even the one they design a system like you say the PLC actually anybody can download it, right? But is it common the automation vendor they will lock up their PLC.
Yeah, that is very common.
Very common. Everyone lock up. If it's not in the agreement, even you download the PLC, you want to edit something, you cannot open.
No.
So this is part of the handover. Is the agreement is this password key gives to you.
Yes, yes.
Okay.
Normally, what happen? They will put a password for the warranty period.
Okay.
The machine warranty period, 1 year, 2 year.
Or this under this period, I will take care for you.
Yes, because
You cannot
it's
change
still
anything.
it's still under warranty. So if someone go and suddenly go and damage things, you will be responsible.
So it's a very common they will lock up until the warranty end.
Yeah.
Then either give to you or whatever.
They give to you, you buy from me or it depends lah. Because that's why my Singapore boss, what he practice is, he will keep the password for 2 years.
Okay.
Once the warranty finished, he don't give password. He go and remove the password.
Okay.
So it's up to you. You do whatever you do.
So
if
after the
anything
warranty
problem,
time, client cannot touch anything.
yeah, of course, that's normal, right?
I don't know.
Yeah, that is normal. You
That's
cannot
normal.
touch. You cannot touch. If
Cannot touch
anything
the
happen,
program.
you just need to call the vendor to come and settle for you.
Okay.
Like this one lah, like a car lah, it's still under warranty. We bring to the service center. After that only we bring outside other vendor to check. Similar concept.
Okay.
So last time I troubleshoot one system during COVID time lah. S7-1500. So they do car timing belt. Okay. So they have a system. The rubber will go to another system. Cut. Okay. So it's like a huge sheet, Okay. I don't know how thick is that. Okay. So they have a roller, 2 rollers in between, like one metal rod lah. Okay. That one is fixed. The 2 other rollers on top and bottom one can adjust up and down. Okay. So for this adjustment, they have another small panel, but no PLC. Just panel like this with the 7-segment display the numbers one.
Oh, okay. You mean the digit?
Yes.
Yeah. Okay.
The display for both the roller and some push button and everything. So to increase up, to go up and go down. Once they done, then they just can start here. Okay. So what happened during COVID time? One of the roller cannot adjust. So they asked me to come and check. So I go and check. I try to back up the program, cannot back up. What password? Okay. Then I tell the engineer, check the password. You ask your vendor to give password, then you can solve the issue. Because no password, I cannot go inside the program. I cannot see what's the problem. So then he say okay. Then he contacted the vendor. Okay, the vendor agreed to give password. No, not password. The program backup. I mean the file, project file. He gives the file. I can open the file. Okay, but actual system I cannot go online because this one is already locked. Because
You can check, but you cannot.
Yeah, I cannot go online.
Okay.
Okay. Then I can open everything and see, because then he give me the wiring diagram. According to the wiring diagram, I see which one control the roller, right? Then I get some outputs. Okay. Then when I go to the program, I see they use function block. Okay. Function block is like the timer, right? Okay. Function block is something like you take one program, then inside the block there's a one logic lah.
Like
That-
subroutine,
Not subroutine.
not subroutine.
It's a code block.
Code block.
Code block means inside there you do some coding.
Okay.
Not coding like so that just normal ladder logic only. Okay? But I can use the block multiple time I can use.
Okay, okay.
Means the same logic lah.
Right.
Like a timer, right? Okay.
Yes.
So what happened for the roller, they use two blocks, two function blocks. Okay? So input will be on the left hand side, output on the right hand side, right? So what I do, so I find out already two function blocks. Okay? Then what I do, I use simulation. Then I try to force the input outputs. I try to force the inputs to check the output can work or not. Can work. Both the blocks can work. One for roller 1, one for roller 2. Then when I doing that, I and my boss was sitting there and doing. Then suddenly I see at the block, second block, there's one value keep on changing every 10 seconds. 1, 2, 3 like that. Okay? Keep on changing. Then I see on top also they have the value but it's not changing. Below can. Because why? Like I said, function block, right? They have a data block. Okay? To store the data, right? So they do some modification in the data block where the second block every 10 seconds count 1. Then I change the value into 99, nothing happened. I change to 9999, nothing happened. When I change to 999,000, all the output off.
Oh, I count until a big number.
All the output off. So what happened is simply put a counter that once you reach this value, all the output cut off.
Okay. So this is modified by the vendor. Or they put in a temporary fixer. At that time it worked, but it doesn't know that count until the end, it will stop the system.
Yeah, you stop the system, then only they can't do anything, but then only they can call them, they can come and do, so they can charge. They want to earn some money that's why. I already find out very well. So I tell the engineer, this is the problem. You request for the password, then I will request for the block password, or I tell them, okay, you only give me the block password because the block is very, very simple block.
Right.
I say you give me the PLC password, I just delete the two blocks, I can create my own block, I can do that. Then the machine maker from China, they say cannot give. So what happened is, I have to take out all the output from the PLC output, go to the relay. From the relay go to the contactor go to the motor. Okay, the same setup like this.
Right.
Okay, because it's a roller, motor is control. Okay, what I did is, from the PLC go to the relay, right? I take out the cable. Okay, then I buy one box. Yes, at the bottom there's a small box, right? I buy one box. I put few switches. Then I just loop the cables between the switches, then go to all the relays. So means now because in their panel they have the buttons, right? Now I don't need to use their buttons. I use my button to go up and down.
Okay.
Because only the up and down only cannot work. The rest of the system can work.
So you physically
Bypass their original output.
Still doable.
Still the company is using. I did in 2020. I thought, because I tell them temporarily I put this. Once the China engineer, because they say they want to come here during COVID, how you can come, the first COVID.
Right.
Cannot come what? They don't want to do online remotely. What to do also cannot. I say my laptop, I have the software, so I can give the access to the guys. The guys can go online. They say no. Okay, I said never mind. Then I modify this, right? Then I tell them, okay, let's say if the China engineer come back ready, you take out the cable from this box to the relay, you remove, you connect back all the outputs.
Yes.
It can work, right? I thought they already changed, In 3 to 4 months back, the new engineer called me. He take picture the old box, he messaged me. this is the one you did by you, right? I say yes. Okay. Now there's another roller also not working properly. Can you come and check it out?
Wow, you can trust them already.
Yeah, then I say, yes, I can check. Then they say after 1 week, you're troubleshooting, then say, no, it's working. But then I ask them, the bottom box is still using or you using the original one? They say, no, the original one still can use, I'm using the bottom one. Okay, good.
China,
They flop. Last time that one company I go troubleshoot, Mitsubishi, they have another Mitsubishi HMI, new Mitsubishi, I mean new system. So they ask me to back up the file also. One I troubleshoot, one I back up and give. I want to give them up. I back up cannot for password. Then I tell the engineer to ask them for the password. You know what they say cannot, it's already patterned.
Oh.
I say, okay, never mind, what to do, cannot do it. Because it's their mistakes. The company mistake. Whenever they buy machine, they have to request that.
Yes,
Yeah.
they have to agree properly
Yeah.
how to handle the
How to handle the project.
handle
Okay.
the project.
Close.
Okay. Do I need to
I
start
don't need to
with it?
close. Okay, let me just minimize it. Okay, you open the file here. Okay, you see? This is the file.
Oh, big one.
Big one.
Okay.
Maybe 90 MB lah.
Oh, so program is small but HMI is very big. Okay.
So you double click, you can open anything.
Okay.
So because I tried before, what I did is because my boss said you cannot open lah. So that time you will find a way to open, right? I find cannot. Then I see PSB file. What is PSB file? Who can open the PSB file? Download few softwares. One of the software is I think Photoshop. Few softwares still cannot. Then I go to
Nothing can be done.
nothing can be done. I go to Google, go to Siemens community and check. Then only. Yeah.
This is a HMI file, but the SCADA visual is not this file. Okay.
SCADA no problem because SCADA is in the PC only. You are not going to download anywhere.
Right.
It's in the project. You
But
create a project, then open the runtime.
okay. We will go to that.
Yes.
Okay.
Okay. So what we can do with this one is you go back to the process, restart. No. Okay, go to choose the file. So you see, I only can restore into this KTP400 basic firmware version 15.
Okay, got it.
Even I can use a pen drive to backup. You put a pen drive in the HMI itself. There's a function called backup.
Got it.
You can go to the setting. You can see the backup. Then from there to USB also you can backup.
Okay, yeah.
Okay, good.
Good.
Alright, you can close. Okay. Then okay, go to the TI portal. Okay, this one is this one. Okay, create new project. Day 4 lesson 1.
Day
Day 3 lesson 1.
Okay.
So we want to see what is function block, what is FC. Yesterday we see FC is the subroutine. Okay. Normal add new device. Okay.
Okay, so it's just
No. Control
PLC.
Yes.
Says if I enter the wrong version,
Mm.
what happened? I mean,
Nothing happened. When you download, it should tell you this wrong version, don't download.
it will just tell you pop up some message or it's
Yes.
different firmware.
Different yours is different format, the online is different format. So, click here, no protect. Okay, then next. Okay, this one uncheck. Next. Full access.
This is where to lock the
Yeah, your password. You can lock the PLC itself or you can lock the blocks also. Okay, next, finish. Okay, you said the wrong version, right? You can right click the PLC because it won't allow you to download because it's a higher version. Because higher version, new firmware. So maybe you do the new projects. Alright. So it won't allow you to download. Change device.
Oh, okay. You can change directly.
Yes. Just click once. So you can see what's the difference here.
Okay, got it.
So the certificate that I got, what? There's a certificate, what the security certificate is building together lines and so does not support improved protection, okay, improve the communication, secure communication don't have here. Okay. Support configuration of SNMP, simple networking, messaging, something. So it's a what? It's a network communication protocol using Ethernet. Okay. Then DNS client.
So now we have a new PLC support.
All this, yes. Okay. Now what we do, we go to PLC tag, show on tag. Okay. What you do, you create, you have six inputs, right?
Yes.
So you click start M1, stop M1, start M2, stop M2, start M3, stop M3.
Okay.
Start stop three modus.
So all this is a high win, correct?
Yep. Output. Motor 1, motor 2, motor 3. Outputs.
Okay. I just make it a little bit, say motor 1 run, okay, so this is our output, right? Running. Okay. 2. Okay.
So 1, 2, 3, outputs.
Oh, yeah, output. So this is
Now go to program blocks. Okay, add new block. Function block. Okay.
So essentially we do is the function of function
FC.
block.
FC, you click FC.
Oh.
FC can use as a code block or subroutine, right?
Oh.
S3 we use as a subroutine.
Okay.
Go to function block. Function block are code block.
Okay.
Okay. This is function block can support. You click here can support the cause and effect matrix
Really?
program. I haven't tried before. How it works? You know like copy cause and effect matrix, right? During but the one during commissioning only they use, right?
Cause and effect is more used for fire system is a very important
Fire system.
fire system because pompa compliance,
Okay.
how they do the engineering, like or if a level 1 this sensor trigger, then what is the effect?
What is the effect?
Yeah,
You
we have to
can
ring
see
the
the
bell,
lamp.
we have to see the lamp.
You can see the alarms.
Yeah,
everything, right?
they not. It's just they not written in the ladder logic or whatever lah. They not tell you that the sequence is like like this. They use a cause and effect. But I'm wondering other than fire, anybody else use the cause and effect here?
I'm not sure.
But anyhow, just okay. But because fire, they don't use PLC also. They use their own
Controller, yes.
Yeah, they use their own fire panel.
Yes, fine. But last time I did one project on programming lah to one of our participants. So it's like the cabin, the offshore cabins. So offshore cabins they have a PLC to control the.
This for oil and gas.
Yes.
Probably oil and gas.
Yes.
They don't use a typical pompa fire panel.
Yeah.
They have to use a PLC to program.
Yes.
And that one is used a cause and effect.
No, the one is using ladder.
Okay.
But because what happened, they asked me to do this program because the program is lost.
Okay.
Asked me to program, but then when I request for the flowchart, they don't have the flowchart.
Okay.
They give me all the wiring diagram and then only I see it as a cause and effect matrix.
Okay.
So that one they use for testing the machine, right? And CO2 level above this.
This is a
Alarm on this
fire and gas, is it?
Yes.
Okay.
So this one is for fire and gas also.
Okay.
CH4, methane gas and CO2, then pressure, everything lah. It's a pressurized level.
Okay.
So what I did is, because they don't have information on the flowchart, I use the cause and effect matrix to do the program. From there I create, but I can't create
Right.
100%.
As far as I understand, this is their engineering drawing.
Yeah, this is how it works.
Right. This is
I
how it
think-
works. Yeah.
Then I couldn't finish. Then I call him. Then he show me the panel everything. Then only he bring one guy to show how it works. Then only I can modify other parts. To on and off.
But so that panel you use is the safety panel already, right?
Yeah.
Oh, okay.
I did from them. Then only I know cause and effect matrix. Then I see come and see here you have cause and effect matrix. But I haven't tried before this one. Okay, never mind.
I
The
don't
name.
know other way to use it. Okay.
Yeah, it's a new. Maybe it's a new in the field. Maybe.
Right.
Because starting with version 18 only they have this.
Oh, before also never had.
Before don't have.
Okay.
That's why for me also new.
Okay.
Okay, you click name, you change motor control.
Okay. So we have a new model.
Okay, function block. Okay, second close that. Okay. So I want to use this as a code block, right? Okay. So code block means you click here. So I can use the internal variables. Okay. So input, output, in, out, static, temporary, constant. So it means whatever I want to do here, I list down here, then I do program with this text.
So yesterday we say the function is really a subroutine because it's like
Because you want to use
call out the function.
Yes, subroutine.
This one is more like a timer.
Yes, more like a timer or that.
Okay, got it.
Okay, so we get a simple program, start, stop, motor. So here you just put the standard name, the start and output, and another one is a stop. Another input is a stop. No, input.
Oh, another input stop.
Yes. No, because the output you must, that one change to motor. Okay, so it depends on whatever type. Okay, in out is some of the tagging we must use as an in out. Okay, like a pulse. You know when you use pulse P. So when you use P, below the P you must put some memory, right?
I don't know. Okay, you mean counting or something?
No, the pulse. Yesterday we use the P and LP, right? So if you, never mind. Of course, like yesterday we use only once, right? Normally below B, you put a P, on top you put the address from where you want to take the pulse. Below is the what? If you store the value, the pulse value.
Oh, there's a new variable for the pulse, become 1 0 very quick.
Yes.
Okay.
So the below one is an in out.
It's an in out.
Yes. So if I want to use the pulse here, so I can use that in out here.
Okay.
Okay. Static is for anything you use from here, the timer, counter, everything. It's like another function block, right? Must use static.
Okay.
Temporary is it's like inside the block only. Input, output, in, out. You can see visibly outside the output.
Here is all variables.
Variables.
Static is okay. Temporarily I know that temporarily is something is like a very local variable lah.
It's a local.
Inside here.
It's inside here. Constant also same. Constant
also a constant variable
is a
inside.
value. Yes. Static also same.
Okay.
Static also is a local variable.
Okay.
But static is special for the like a timer, counter, because timer, counter all is another blocks. Another function block.
Okay.
So to do, if I use that function block here, then it becomes a static.
Okay.
Okay. So
So this is also a variable. It's a pulse variable. It's in out.
Not exactly pulse. Pulse is just an example.
Okay.
Because for the pulse, the variable at the bottom is an in out.
Okay.
Okay. Some of the functions when we do, some of the blocks when we use, some of the tag we must use an in out tag.
Okay.
Okay. And later we try.
Okay.
Okay. So now for now input enough. Input and output enough. Okay. Close this. Now you do the program with this input output.
Start, stop, stop.
Yeah, just start, stop, motor. Okay, double click here. No. Okay, click the arrow. So you see, you have this and also this. So you ask me, right, why global, correct or not? The percentage symbol.
Oh, okay.
So the percentage symbol means I can use in the main OB also can, FB also can. But these three, I only can use inside this block.
Motor control.
Yes, it's a local.
Okay, got it.
Okay.
So I start, and then I will receive a S.
S also can, normal output also can.
S is good for me. Lazy people use S, right? Okay, motor. So we have a start and stop.
Enough.
Okay.
Okay, save. Okay, go to main. Actually, yeah, all the blocks you can call in the main also can.
Okay.
Okay, you take the FP, put it here. This function block.
Oh, pull it, drag and drop.
Okay, wait. You see, when you add, it's like a timer, right? Single instance, DB. Okay?
Okay.
So you put motor control 1. Okay. Yes.
Ah. This is a function block.
Yes. The FC also can do same like this. But okay, I'll tell you what is the difference. Okay.
What is an EN or here?
EN is enable out.
What is mean by enable? I mean, just curious.
Enable
Like,
if you no. If you put it interlock here, if it is not enabled, the program inside won't run.
Ah, so actually, okay, now of course I'm assuming all the time is scanning this function. But actually, if I can do something like only if I press the button, then you can start the motor with
Yes,
start
yes.
button.
Correct.
Okay, got the point. Okay.
If no means if I press start, the motor won't work until I enable this line.
Enable. Okay, got it. Yeah.
Okay.
Yes.
So now you see function block, right? You see if I didn't key in any address here also, it's still fine. Okay, still fine. Okay, you take another function block, put it beside here.
Right. Here we got it.
Wait a minute.
Okay. How we do?
You take another function block. Function block, put beside here. Drag.
I try to think that this is just now we create a function block.
Yeah.
When we drag it into the OB, it become a DB.
No, it will create a DB.
It will create a DB.
So what you see in the DB is whatever this one you can see in the DB. You open the DB.
Or DB is just like this only.
Like DB is like a tag table lah.
Or it's like a tag table.
Yes, but it will keep all the data of your function block. So when it's running, you can see here, you can modify here itself also can.
So
You can retain the values also can.
So function block is really just this is a template here. You
Yes.
drag it, then you copy paste more and more and more.
Yes, can.
Okay, got it, yeah.
You go to main OB1.
OB1.
You add function block another one.
So I will drag it here.
Yes. So it's a motor control too. Okay, so now you put the start M1, stop M1, motor 1, start M2, stop M2, motor 2.
Question.
Yes.
Enable in this one I know what you're saying lah. But
So
this
enable
one-
out.
Yeah, there's no meaning for the enable out, right? Because your output is not from here. Your output is
Yeah,
from
it's just if it is enabled, then I just out. That's all.
Yeah, I mean, I think of just now what you say. I imagine I say okay, we have a two function block here function block, which is to command two different motor.
Yes.
Says the condition of motor to be commanded through this function block is I have to have somewhere switch it to automatic first. Okay, probably this one. If I switch here to automatic, then you can command this one,
Yes.
and you can command this one also.
Yes.
If I want to do something separate, differently,
Then put below.
below.
Ah.
So it's like motor 1 automatic, switch here, then this one enable.
Yes.
2 switch here,
Yes.
then enable.
Yes.
But this output here, actually whatever I put here, it doesn't have any meaning here.
Actually, here also can put interlock.
You also can put it out,
Ah.
right? So if I put, let's say I put it
You can take this output, can put it here also. Means, okay, here I put interlock auto, right? Okay, I say I enable the auto. When I start this motor on, let's say I put timer or something. After the timer, I take one data, I put it here. Then only this motor can work. Okay.
So you, okay. This line here is a energized or de-energized, right?
Yes.
It's considered a 1 or 0 already,
Yes.
right? As long as I say that in a function block how I put as long as the in is a 1, in is energized, how will we automatically become 1?
Yes, correct.
Or it's always follow the EN?
Yes, because there is no program. You cannot do program for the ENO.
Okay.
You only can cut off the signal only. That is going to the EN. You only can
inside only.
yes,
Yeah.
it's inside. You just like you said, you only can energize or de-energize this line only.
Okay. Clear. Okay, so this one is always follow the EN.
Yes.
Okay.
Okay, so you add the start stop motor, start stop motor, start one stop one motor one.
Okay, global. So this is so this is start 1. Stop 1. And 2, right? Okay.
So you just save, download, and test. One motor 3, motor 2, right?
Save. Download it.
Yes. Okay, load.
Okay, so now I have a working program. So what is this is
So just press that stop, you can see it's on off.
start running. Stop running. Start running. Stop not running. Okay.
Can?
Can.
Okay. Now, what we do the same thing in FC. The same what happen.
Okay.
Okay, you go offline. You just add new block.
Function.
Yeah.
See, I can add data block to it. But because data
Data block is like a table only. There is no programming inside.
Yeah, actually the data block has come from the function block, right?
Yeah, that is called instance data block.
Okay.
Means instance data block means it's just store whatever data from the function block. It's called instance data block. Okay?
Okay.
No. Okay, you're correct. The data block, the DB1, DB2 you have, right?
Yeah.
Yeah, it's all from the
Function block.
function block. Means it will only store whatever data from the function block.
So I'm wondering if people do programming, anyone has to add a data block because either they add a
Yes.
function or function block.
Yes, data block is the mostly used.
Mostly used.
Yes. So the global data block, right? You click the data block. The global, okay, this data block all is for the timer, counter, all that. Right. You click that. This data block is for the function block you created.
Oh, data block not necessarily only for function block, it can be for other things also.
Yeah, of course. Others like the timer all you will have a data block, right? Remember the timer you take, you have a data block coming?
Yes.
And you have a timer.
Oh, okay. Yeah, because the timer itself is a function block.
Yes,
So
okay.
and everything is a function block has a data block.
Yes, everything function block must have a data block.
Okay.
That is this one and the others.
Okay.
Okay, all this called instance data block.
Instance. Okay.
Means
Instance.
instance means it's only store whatever data from the function block you use.
Okay.
Okay. But global data block is similar to your memory. It's not related to anything. It's not from any block or something. It's just like a normal memory, like a PLC tags. So that memory, that data block you can use for the alarm, your SCADA, data transfer, everything you will be using data block. Like I said, memory and data block both are same. Memory can be value can be become 0. Data block can retain the value. That is the data block. Global DB.
Okay. I think I will
But-
know when I use it. Yeah.
Yes, of course.
Okay.
Here now you get some idea, but when you use that only you know.
Okay. Got it.
Okay. You just FC.
Function.
This one also you put it name like a motor control. I don't think so. Can put same name. Try it. Motor control. Run.
Okay.
Control run. Ini. Okay. So inside also same.
Yeah.
Here also I can do normal program that is called subroutine.
Okay.
And also I can use as a code block. Means I click here, I can use the same thing. But here you can see don't have static. Okay? Why? It also got equal output temporary constant but don't have static. Why is static? Never mind. Static later when we use static in the function block, I tell you why here don't have static.
Okay.
Okay, then you understand. So now same thing. Input you add a start stop, then output one motor.
Here is defining all the variables inside.
Yes.
Start, stop, auto. Okay.
Then temporary constant all that lah. Okay. Now you create a program.
This is this is exactly the same as the very
Same thing?
Yes.
Then you crawl the block in the OB1, do the same thing.
Wow, use the empty pocket.
No.
It's a drag and drop also.
Drag and drop.
Okay. Just now it's a function.
FC. Yeah, drag and put it down the second one here.
This is a function. This is a function block. Okay.
Okay, you see, same thing, but FC don't have the data block. The FB have a data block here. Okay, and you see, if function block, right, if I didn't key in the stop button, still is acceptable. Okay, but for FC, you need to key in all the data. Okay, so it means normally what they do, you can do like this also. For FC also can do like this, no problem. Okay, but normally they do like for one control. Okay, like if you have a similar control, like one motor only you want to do like FC, you can, no problem. Let's say you have three or four motors, you want to do like function block. Then you can use the function block to do. You know why? Because like let's say I have 5 motors. 3 motors have a motor trip function. Motor trip. The motor number 4 don't have. Then let's say motor number 5 don't have overload switch. So I can leave it empty, that space.
You mean one of the difference between FC and FP is
The DB.
the DB?
Yes.
Okay, the DB. There's a main difference.
Main the difference. Because DB itself do a lot of things. Because DB can save data. So if I didn't key in anything, you just remove the stop button here.
Right, let's say I remove here.
Yes.
What will happen? It will always
False.
assume it's as false.
False. It's always
False is
false.
0.
Yes, only 0, that's all.
But if I leave it 0 here, I leave it nothing here,
Cannot. You can download also.
you cannot download. But if I leave it 0 here, it can download. It will just in the table
Always
write it as false.
Yes.
Oh, okay. So one is a very how you say compulsory logic. You must have all the in and out
Yes.
wire correctly.
Yes, correct.
One is you treat it as a calculation. If you have no input,
No input, it will automatic.
then I assume it's 0. only.
Yes, correct. And also, now one is using DB, right?
Yeah.
You can change in the DB also.
Ah.
So that one later we do timer so we can understand better. Okay, now you just key in the motor, stop motor 3, stop motor, all that.
Question.
Yes.
This is about the cinema seat yesterday.
Okay.
We have I, Q, and
Okay.
everything.
Okay.
DB also have this kind of
Yeah.
logic.
Yes. DB is the same, but that one is during the global DB we use that. This DB we don't use. Because this DB we don't use as a address like a memory. Because we just this one whatever data it just save inside here. That's all.
Because this one, how you say, it take up a lot of seat also. Because you have to like, yeah.
You have no
Because
need to
there's a
worry
variable
about that.
inside. There's a
Actually
variable.
DB you don't need to worry about that.
Okay.
Because memory is they already give you this memory, we can use the memory.
Right.
DB you need to create first.
Okay.
So when you are creating, the number is already there. So you don't need to worry about the numbers.
Okay. Oh, you mean because it's borrowing it's a template only lah, but if you implement it, it's borrowing the I and Q and everything from other people lah. Not to say borrow. It's like matching.
You mean this DB?
I'm just wondering, this DB,
This DB, that's
will
okay.
they take up when they say because I imagine this one says for instance this stop here, this stop has a false value, right? It's 0. Meaning to say somewhere in the program has a bit must save it as always 0 here.
Yeah, because it will save inside this DB2.
Yeah, so if you sit inside DB2, then theoretically DB2.
But you can use anywhere the DB2.
Okay.
Ah.
Only for here. So I don't have to worry about the logic of this.
Yes.
The
That
naming
one
or
is
whatever.
we will be doing in the global DB.
Okay.
But in the global DB also you don't need to worry about the numbers. Because why? You need to list down first, then only you can use.
This is a global one. I mean here this is in the globe. Okay. I will go forward and then
Later we do that.
we see.
I know where you which question you
Yeah,
ask.
just wondering, and then in the naming or whatever, any
No. That one
there's no consideration.
no need to worry about that.
Okay, don't need to worry about that. Okay.
Okay, now you key in this start stop. The start entry stop.
They are very similar. One is more loose and numerical. One is very hard logic.
Yeah.
Okay. So this is a 0.0. And motor is
No. 0.3 right?
motor 3. Okay.
Must use more.
Okay.
Now you press this.
Save project.
You press the second motor and go down. Third motor. On.
Okay.
No, you put wrong. You put the start stop. Start entry, stop entry.
Oh, okay. Reverse a bit.
Yeah. Because on top you remove the stop button, right? That's why. I mean you put back the stop button on top. The FB. This one you put back the stop button.
Okay. Okay, now it's on 5 again. This is 4 and 5. Okay, light on. Light on, but not. It must stay.
Must stay, right?
Not stay.
Not staying, correct? Yes. That's right. It cannot stay. In the SC, you cannot, it won't stay. The output. So if you want to keep the output to latch, hold, you must use in, out, input, output. You go offline, I will show you. You go to FC. Okay. This output, so it won't set reset. Okay, so what you must do, this output, you put on, move to in out. Yes, you number 6.
Right.
Yeah, can. You click on number 6. Yes. In out only can hold, can latch.
Okay. Just have to know that in out only can latch.
Can latch because
Just now
that's how the FC works. The FC, FB normal.
FP no, FC in out must
In out.
only can do in out to latch. Okay.
Yes.
Okay. Then save it.
No. Can you see red color, right? You right click because you do some changes going on.
Yes.
Okay. Update block. Yes. Okay.
You recommend you.
Because it become like this. Because you choose in out, right? It will come on this side.
Motor will come on this side.
Yes. For this, because normally input is left hand side, output is here. When you choose input out, in out, I come like this.
Okay.
Nothing happen. Just that it become like this. That's all.
Okay.
So normally FC they don't use for like these programmings.
FC. So people normally do programming don't use FC.
FC they use as a subroutine.
Subroutine.
Like yesterday we do.
Okay.
Subroutine can use. This one we call code block. Subroutine means you directly do some program there.
Yesterday when we code, we also drag it, right?
Drag, but it's like we didn't use the internal variables one. The local
okay.
tags.
Yesterday when we do, we don't have this all this
Yes,
stuff here.
correct.
We just call the function.
Call the blocks because the block must be run.
Right.
Okay.
And that is really a subroutine.
Subroutine, yeah, because inside the block I use physical address to do the program. I didn't use the local tags, local variables.
Okay.
So this is a code block. Code block means I'm using the local variables.
Right. I get your point. So people usually, even though they're both very similar, people usually use FC2 as a subroutine only.
Yes.
And use function block as a real function block.
Blocks, yes, as some blocks. Because one of this is the some problems. Another one is a function block don't have static.
What's that one?
Statics. The FC don't have static.
Okay.
Okay, so later we see what is static lah.
Okay.
Okay, now download test.
Okay, it worked. So
Now it work, right?
Yes, so we can match.
But if you do like a latch and using a coil and branch, now you're using set right?
Right.
If you use coil and branch, I will show yellow color.
Okay.
Because it's an output means only can use as a coil. So you can use as a coil, you cannot latch it or cannot use set.
Okay.
If you use it as an output. If it is input output, it's like you go down.
You say when I use a function.
If it is in out, then it's okay.
Okay.
If it is just output only, you can only use as a coil only.
But you cannot use S and R.
S and R cannot. Coil and latch also cannot.
But it didn't give you error whatever lah. It just keep quiet and then you run only. Actually.
Yeah.
Okay. But at least there's a concept here. Okay.
Okay, good.
Okay.
Any question? Okay, here.
So far so good. This one I still not clear how this I/O work, but I think later will.
It's an input output. Means you can energize and also you can use as an input. Like a relay relay.
So it can give.
So means here I can put I address also can, Q address also can.
It can both read and write or what kind of situation. But anyhow,
But I manage it.
yeah.
Okay. So we go for break.
Okay, okay.
Yeah, break. So today going back.
Yeah, so they're going back.
go to OB1. Okay, OB1, FB1. Okay, can you close this? So I want to add a timer. So I want to add a timer. Okay, click here. Yes. Normally open. Normally open first.
Oh, okay.
Okay, motor. Okay, then timer. Okay, now. Okay. You see, so if I choose single instance, okay, so it will create its own DB. Okay. If I use multi-instance or parameter instance, what happens? This one will share the DB with the function block. Because function block have one DB, right? It will share the DB with the function block. So what happens? It will these two will go into the static. Okay. So you see, you click multi-instance. So if you call function block multi-instance, it states the data in the instance data block of calling function block. It means not in its own data block. These two same. Okay. But what is this difference? Means, okay, you see, get fewer instance data block, right? Okay. So means it won't create another data block. It will share with this DB. Okay. This one will create another DB like normal like normal timer. Okay. This one, click here. Okay. This one also same like this one, but this give you option of defining the instance for this FP call during runtime. It means later you want to add a DB for this timer. Later you can add also. Okay. So normally this is just timer, right? So we just use multi-instance. Okay. You click multi-instance. Just put timer 1. Okay. So you see it won't create a DB
Because
it's sharing the DB here. So what happens? This data will go into static.
which is supposed to be shared.
Can you see it go into the static? So in FC don't have static, right? So what happens if I use the timer, it will automatically create 1 DB. Okay, good. Okay, you close.
Okay, I close first.
Close first. Okay, now that one you reset the motor. Okay, now the timer I don't want to fix the timer. Okay, I'm just able to change the timer value. Okay, so what I do, you go here. You add 1 input, 1 output. Timer in, timer out, or timer run.
So probably it's not Boolean.
What is this? It's not Boolean, right?
Yeah.
Timer.
Time. Okay. So this here is all actually this is all the type of the variable inside the PLC.
Yes.
So many
So many.
time. Okay, time.
Some of that is from the hardware. If you see HW, it means the hardware data.
Okay.
When you use Modbus, all you will be using the hardware data.
Okay. Okay. So I do time.
Okay, good. Okay, now close. Okay, put it here, timer in, timer out. Yes.
Why it consider this timer one as a variable?
Timer 1 as a variable.
Yeah, because I
Okay.
now
Why? Because why is timer 1 become variable? You mean why timer 1 become variable or what?
yes, why
Because just now when you add a timer, it give you three options to choose the function block. I mean
Right.
DB type.
yeah,
One is the global, I mean the DB.
yes.
Means it will create its own DB.
Mm.
Another two is you use the same DB.
Share, yeah.
Share the same DB. So
Yeah.
when you share same DB, this one will go into a variable. So this one, can you see the timer one will go into my static.
Mm.
So that's why when you choose it, what available here. Okay, why is available? I know what is your question. Okay, for that I do one program for you. You
Okay.
put timer out first.
Yeah, because I was just wondering if this is a variable, then how it behaves.
How to use the variable?
Yeah.
Can.
Okay.
Okay. Now I want to use the variable. Okay, what you do? You go here. You go up. Go up. You put motor 2. Sorry, the output. Output, yeah. You add one motor 2.
Okay. Motor 2.
Just motor 2. Yeah. Okay. Boolean. Okay. Close.
Before it is 0. Okay. Okay. Close. Yeah.
What I want to do, you click here. Normally open.
Chocolate.
Right, open. Okay. I want to use this cube. Okay. So you click here. You click here. I'll show you. Double click. You click this one. Okay, can you see timer 1? Cube.
Okay.
Then you click here. You set motor 2.
So here is I choose timer 1 Q. I can actually choose anything here.
Anything here. So
So it's not exactly a timer
actually
one,
this
it's a-
one you can put it here itself. You can also. But I'm using the timer 1 cube.
Yeah, I understand. You can choose timer 1 Q, but you even can choose, I don't know, but because here is only 1 Q, is a boolean, right?
Yeah, of course.
Okay.
Okay, and below here you add reset the motor below here. Yeah, you add a branch. Because then you will add a reset motor.
Okay.
Okay. So we will be using this PLC next week.
Oh,
That's why
that
I'm
one.
preparing, yes.
Okay.
Because this one got analog output. Actually that one also can use.
Yeah. Okay. Okay.
Okay, now we go back to the OB1. Okay, so it's red color means because you do some changes, right?
Yes. So refresh it.
Update block. Okay, now. So the motor 2, if I didn't put anything also no problem. Right now.
Yes, because this is a DB.
DB, so it will. So what happened? Whatever changes here happen, it will just save inside here.
Right.
It no need
No
additional
physical output.
a tag there.
Okay.
Okay. Now, you see another one of the advantage of DB. Okay, click here. You put 10 seconds. Just put 10S.
Oh, yes, okay.
Okay, then here like 10S or 15S. Then you download. Okay, so can you see it's asked you to reinitialize.
Right.
Why? Okay. So earlier this DB, right? Inside this DB, what you have? Start, stop, motor, only this thing. Now you do some modification, right? You add a timer in, timer out, motor 2.
Got it.
So it's a new block already. So that's why you need to reinitialize the block. So what happened when you reinitialize the block? Earlier saved data, let's say already have some timer values, everything, let's say 15, everything. So it will reinitialize to according to the new settings.
Go back to the default value.
Yes.
Okay. Okay, got it. In this case, I'm saying that with a function block reinitializing, let's say this function block is forcing the motor to run, and the default value is not running. So when I reinitialize here, it will stop everything. Because it go back to the
top.
not go back to the default value. Default value
Becomes, I know what you mean, the true
Yeah.
false, right? Okay.
Yeah.
So it will reinitialize, yeah, of course, it's go to stop.
But depend on how people program it lah.
Yeah, depend on what are the changes you did lah.
Okay.
Okay, now you close this one. So FB, FC, DB. Okay, we are on the right track lah. Okay. Monitor. You close this one. Okay, close this one. Okay.
So I have a
Okay. I just press that. Can see, can run in the timer.
automatic running second.
So after timer, after 10 seconds, the motor 2 will on. Because we use the timer.q. Can you see? Double click, yes.
Okay.
Because after the timer it's on. Okay, you monitor. Can monitor. Okay, you stop. Okay, start again. Okay, go down. So once you reach the 10 second, this one will energize to set this.
Okay. I'm a Q.
Yes.
Motor 2. So now motor 2 running again.
Yes. Okay, but click here.
Oh sorry.
You open this. Okay. You press stop. You test motor 2 with the other motor.
Running.
This one. Yeah, this one.
Okay.
Yeah. Click. Can you see? You can see here. Right.
Right.
Because why? Because
motor 2.
yes, because you open from motor 1.
Okay.
You didn't open from the motor 2. Main.
I have to go inside here.
Yes.
Okay.
Then only you can see.
Okay. So
Okay. Right. Because this one is very helpful when you do troubleshootings or do some changes. Because let's say when you do commissioning, the motor value is not enough. Let's say they set 45 Hz. Then you see 45 Hz not enough. You need to increase 50 Hz. So sometimes the value will be inside here. They fix. So you must go open and see. Right. So this is how you open. So if you want to, let's say you have few function blocks. If you want to monitor the blocks logic, because if you see the block only, right, you cannot understand the logic.
Right.
Because it's just a block only, just input output. You don't know what is the logic.
Yes.
So if you want to see the logic, you must go inside the monitor.
From the OB double click.
Yes.
Right.
So from these blocks, right, not necessarily must be in the OB. Can be in the FC also. The FC, that is subroutine.
Ah, okay.
I will show you how it works. But don't worry, last day actually I'm planning to do a big, not a big project. It's all small project, but like a big, all so many FPFCs. That's my plan. So you have OB1. There's no program inside. You can call FC as a subroutine. Inside here, I call the function block 1. This one is DB1. And I call another same function block 1. Then this one will become a DB2. Okay. Then I call another FC2, for example. Inside here, I do some programming. Okay. So let's say inside here no program. Inside here is just these two blocks only. So this one is the motor program. This one for the motor 1. This one for the motor 2. This one name is the motor control. This one is the conveyor example like. Then I create another one, FC3. This one inside here I do FC3 2 times or 3 times, can, no problem. The FC3 also can use as a code block, right? Same like this one, right? So this one is the scaling example like. This one I do is the AI scale, this is the AO scale, something like that.
This level of function or sub, it can be, I don't know, considered like unlimited, right? You can.
Yes,
Yeah,
it's considered unlimited lah, because if you see the manual, FC you have around 250 FCs, 250 FPs, if not mistaken.
Or maximum for one PLC.
But that is only for 1002, 1005 is not that bad.
Oh, okay.
Because I need to the manual, because actually I'm creating another manual for this. Whenever I have time, I'm just going to install another manual lah. Okay, with the proper, because always I have get complaint. What happened is because the manual the old manual I give you, right, everything is there. How to upload, how to create program, how to download, how to do HMI, everything is there. More to step by step. But how to use timer, how to use counter, how to use the blocks, it's not there.
Okay.
So
basic
it's like that is more to logic, right?
Right.
It's not like step by step. Manual more to step by step how to create, but no logic, how to create logic, all the content. So that's why I'm creating one proper one. Okay, inside there I'm doing all the function block, and maybe I will put 2 or 3 example programs with a flowchart, IO, and example programs. Simple one. I'm creating that one. So once I'm done, because I know in my WhatsApp normally I will save your name as student PLC Chan TIA. So I know who is doing what PLC, what training they come. So once I'm done, I will forward to all of you.
Okay. Thank you.
Okay, so I'm creating one. Now only how many pages? Now only 30 or 40 pages. Still got a lot. Now only 30 pages. Now only until creating new project. So the 30 pages is the numbering, the addressing, the data types. Okay, because this one, the earlier one, you see, there's more on the CPU history, all that, Siemens history, all that. I take out all that. No need.
What you do, is it like have an affiliation or a relationship with Siemens or not? Because I aware, or I don't know.
No.
Siemens have a certification, right?
Yeah, Siemens is certification.
Like
I know what you mean.
Yeah.
The problem is if you want to do in your certificate, you want a Siemens shop or Siemens certified, right?
Right.
Okay, you can apply for that.
Okay.
Some training center they are doing like that also. Okay, but you only can do Siemens training.
Or it's not. I mean, so they
Other
cannot
brands.
like they engage you to be
Trainer.
freelance trainer, something like that.
Not yet. Maybe in the future. Who knows?
Okay, you can do that actually.
Yeah, I can do that because that day also there's one company. Because now what happened? Siemens no more providing basic trainings on that.
Okay.
Siemens
They provide
advanced or
Okay.
more specific, like Siemens PLC and HMI control. Siemens VFD training.
Okay. Okay.
But very expensive, 5 days training 9,000. Very expensive, I know.
A
2
very
days
very
training,
detailed and advanced training.
No.
Not also.
Because 2 days basic training. Okay, 2 days, let's say 2 days, what was last time? It's an analog training, I think. No, PLC and HMI. 2 days, what they can gonna teach you.
Okay.
Okay, the price is for the brand.
And a certificate.
Yes,
And the
Siemens
fee.
certificate, that's all. Even last time I request, because there's one training center called SG Academy. So
Okay.
they are Siemens certified.
Okay.
So when you Siemens certified, actually Siemens can give you the training kits for you.
Okay.
But the problem is, only can do Siemens training. That's the problem.
Your center only can
Yes.
teach Siemens.
Yes,
You cannot
that's
teach
a-
Omron and
Yeah, I
everything else.
cannot. That's what I know lah, but need to try test it, check again. So that day I asked them, they offer 5 days training. It's another training center. 5 days training, Siemens training, 5,800, 5,800. Okay, Siemens training, Siemens PLC lah, Siemens PLC. Then I asked them, it's a basic to advanced. Okay, no, they put basic to intermediate, they don't put basic to advanced. Okay, I see the, because this one is in YouTube, so I see the course content is very basic.
Okay.
I already know. Actually, what I thought is maybe I can go for something which I
Oh, you
don't
don't
know
know.
something, right? So I want to go and just check lah. And also I want to see how they teach, what the equipment they use, okay, all that for that, okay. Then I see for 5,000 I need to pay, and I want to go and see, the cost structure. All I know already is just the basic intermediate level only, not advanced at all. No drive, just the PLC, HMI, or that. So whatever, they more concentrate on the theory parts
Okay.
first. The first day are more to theory part. What is PLC? What the PLC can do? What is the digital I/O? What is analog
all that stuff
I/O?
lah.
So more on that. What I do, my style is, okay, I will teach the basics first. What is PLC? Let's say you don't have the basics at all. So of course, I will spend like, for you I have the slide, I think around, before lunch you already finished the slide, right? The first day.
Yeah.
Yeah, but for if anyone beginner, after lunch only I will do the addressing part, everything. Okay, because they need to understand, because they don't ever see before, never
Okay,
seen
okay.
the PLC before. Okay, then, but digital I/O, analog I/O, I don't need to teach them. Okay, this is 1, this is 0. No need. I just tell them digital I/O is on off. Later on, when you do programming, you can understand better.
Yeah.
Yeah. So analog also same. Sometimes people think analog is tough. Analog is tough. No, analog is not tough. Analog is just a reading only. Actually, analog programming is very simple.
Okay.
Basically, it's very simple compared to digital. Digital is, of course, digital is simple, on and off. But analog also simple. You just get the value. You just need to know what is the reading. Let's say you see some value. What is the meaning of this value?
How to scale it?
How to scale it?
Yeah.
Once you understand what is the meaning, you can scale it, no problem. It's just
Yeah.
normal mathematics only.
Yes.
You need to know how to use calculation. And Siemens, any brand, they already have the block for scaling.
Scaling.
You don't need to worry. You don't need to do your own calculation. After scale, what you do? you only can do two things. One is, okay, three things like for example. One is you show in the HMI.
Right. Display.
Another one is you want to control something.
Yeah.
How to control?
The PID then.
No, not PID. For example, if you want to control, like when the temperature high, I want to on an alarm. How? As a digital means, I just use normally open.
Right.
But this is the value. I use comparison. I compare. I put set point, compare.
So it's a function block called comparison.
Yes, it's not a function. It's just like they call just instruction.
Instruction.
It's an instruction. So it's just a compare instruction. You put a set point, then you put your temperature value. Once you reach the set point, it will give you one signal, on-off signal. You use that signal to on something, off something.
Okay. As simple as just a comparison.
Just like a normally open, normally close only.
Right.
Just like
how people
digital.
threshold up.
Yes. What is it? You get the analog value, convert it, compare it, make it like a digital signal. That's all.
Right.
Number 3, you can use in the PID.
Okay.
These 3 only. So normally PID no need. These 2 only, very basic, very simple. PID like a bit advanced already.
Okay.
So what happened is, let's just we come back to what you asked just now. Okay. So that's the problem. So Siemens now they don't do trainings. They do trainings very specific. Whenever they release new hardware, they do training. Drives. So they will, of course, they will post. Okay, this week I have training. Their style is our competitor. Actually, they are our competitor. But our competitor, their style is they will post a date. They will wait for, let's say, at least minimum 4 participants. Then only they start the class.
Okay.
We don't do that. Minimum 1 also we start the class. We don't want like this week empty. We don't want.
Okay.
So at least one person coming. Okay, can we start the class?
So you have a
So
very
the more to
full
personalize
schedule.
training.
Right.
Yeah, more
This
to
is
training.
good for me and good for the student. To be
Yes,
honest.
yes. Actually, if you ask
Very, very
me,
customized.
2 to 3% is just nice
Okay.
because you have different understanding, different question. Another guy have different understanding, different question.
He see things from a different
Different
perspective.
question. So this is a different question. His background is different, so he can share knowledge everything. So 2 or 3 is very best one.
Okay.
But all must be basic. Let's say he come for basic, he come for basic, he come for basic.
Okay, okay. Cannot
Now
be different than
for me, now you cannot sit with basic because you already know some
different kind of a background.
different type of
Yeah.
background you already have.
Yeah.
You are very fast. You very fast to understand. You can relate to whatever
You
you can relate all that. So then you must be alone. For me, if you ask me lah, you must
cannot
come
be
alone.
with a junior
Cannot
guy
be,
lah.
because if you
Yeah.
come with others, you will waste your time
For your
because
point.
you need to wait for others.
Yeah.
If all basic, then it's just nice.
Then they can learn from each other very
Yes.
fast. Oh,
3 is best. 3, 2 is best. More than that, 10 packs out.
too slow already.
Too slow. Too slow. Only few because sometimes company can send 10 packs, right? Okay.
Not all can understand.
Actually, not like that. Not all really want to learn.
That is the point. If because I'm paying by myself.
That's
I
so you want.
maximize the value
So
here.
you maximize
Learning
your
here.
money the value for money.
Yes, yes. If they are paying by the company, they are.
No, some they don't not interested. Some they come just join. Some of course has 10 packs, at least minimum 3 or 4 packs. They really want to learn because they are really doing the job.
Right.
Very rare. All the time is doing job. Like a few weeks back, I do training for Foxconn. Here Foxconn. They request for intermediate to advanced training.
Foxconn from Singapore.
No, here one.
You got Foxconn
Yeah.
in Johor?
Yeah, Johor Foxconn.
It's a factory.
It's a factory. They produce ink.
But Foxconn is not the one produce iPhone.
No.
Foxconn, right?
Yeah.
Oh, they got produced printed ink as well.
Yeah.
Oh, okay.
Because they got so many
Business.
business.
Okay,
So this
okay.
one is they produce printed inks.
Oh, okay. So they send a lot of people in, but
No, I go there.
oh, you go there.
Go there. So they are advanced and intermediate to advanced and bags. All the time was involved in the training. Because all the time they are basic, they are doing the job, they are doing troubleshooting. So all of them involved, all of them ask questions. Sometimes some company will go only 3% or 4% like really involved. So the first day itself I know already. So what happened? I do the training, but I only focus the 4. So I try to give maximum knowledge. So whenever I give project, the others do project, so once they finish, I ask them to try others.
Ah.
I ask them, okay, I add this, okay, once you finish, okay, you do this, try this.
Interesting. Being a trainer. Okay, yeah.
Alright, okay, now this is how you can try. There's another one is global DB. Global DB stand alone because no need to call anywhere. Okay?
Yes.
No need to call anywhere.
Yes.
Okay? Alright. So now, so this one normally when we use, okay, for parameters like values, like HMI button, right? Yesterday we used the memory, but normally they will use DB.
Like the set point is a DB. That's
Set point, the buttons, all the DB. What happened? Very simple. They will create one DB,
oh.
HMI, whatever you want to do in the HMI, everything they will put in there.
So this DB like is interface between the HMI.
HMI. So whatever you want to do in the HMI, you take from this DB.
So they do not call from the function block whatever itself. They
No need to
call
use
from
the-
the DB.
No need to use the memory.
No need to use the memory.
But you know yesterday we do the HMI, right?
We use the memory.
Memory, MD,
Yeah.
M0.0, 0.1, something like that, right?
Yes.
So we are confused. We're confused on that part. Not confused. We need to see which memory to use, and you say like, okay, we can put like from this memory to this memory is boolean. This memory to this memory is what? Integer, double integer, and from this memory to this memory is like HMI, right? So you don't need to do that.
Okay.
You create one DB. Inside the DB, whatever you want to show in the HMI, everything you create that.
Okay.
Then,
okay.
once you created done, then you can use that DB in the HMI.
Okay.
Then, another one is alarm.
Okay.
How many alarms? Actually, you can use the memory also. But memory means, like you say, because memory they already give, okay, this much memory you use. Programmer only they need to select, okay, from which memory to which memory you want to use as alarm.
Okay.
Instead of using that, I can create another DB, list all the alarm there.
Okay. Okay. Got it.
So that is the global DB. So means global DB similar to actually same like the memory. Similar to memory. Only different is global DB can retain value.
Retain,
Yeah.
you need to say is you off on.
Off on the value can be there.
Oh. It will not reinitiate.
No, not reinitialize.
Or need reinitialize,
No,
yeah.
no, no. Reinitialize is if I doing something, if I add something new in the DB, then we need to reinitialize to the actual value, start value.
How about other DB? Let's say another DB.
This
Yeah.
DB, okay, there's a 2 DB, yeah. Okay. This one we call global DB, this one we call instance.
Oh, okay, the different, okay, whatever is not global is called instance.
Instant DB is depend, it will only keep data from the function blocks. Global DB is keep data that you created. Because global DB is empty. You need to create all the data.
So I create, you need to say, but when I create a DB, essentially I key in all the default value already.
Can also.
Okay.
You can key the default value. Actually, not default value, it will show, we call start value. You can
Start
create,
value,
yes.
yeah.
We do that. We do that
Okay.
in the analog program.
Okay. Okay.
So we know how to use the DB.
Okay. Okay.
Okay,
Yeah.
good.
Okay. Good. Yeah.
Now, this one already downloaded, right?
Yes.
Okay, now what we do, you go offline, you erase this, just erase, delete, make it zero. I just erase, okay. No, not zero. Okay, that's all. You just click here.
Oh, okay.
Now zero one.
Okay.
Zero one. Okay. Now download. Because I do some changes, of course I need to download. Correct or not? Okay. Monitor. Can you see the value 10 seconds are still there? Why? Because earlier you put 10 seconds, right?
Yes.
The value already go into your DB. Okay? So the value 10 seconds will be always there until you go and change in the DB. Or if you reinitialize the DB, then it will go back to zero.
This is a DB. So no
You
matter.
go to the DB. Actually, you can open the DB. DB1.
So you mean
Monitor?
this value is not in the program, it's in the DB.
Yes.
The DB and program is separate thing.
Yeah, it's just okay. The program is in the block function block.
Right.
What happened? The DB will take all the not program, all the values.
Okay. And store that.
Store the value inside your DB.
So today if I understand correctly, today the programmer have a program. There's a DB 100 variable inside. There's a program with all the logic inside. And then he update the program. What he changed is a logic, how the
Yes,
logic works.
correct.
But the DB he did not change. He did
Yes.
not update it.
Yes.
So the value is
Still will be there.
still will be there.
Yes, correct.
Then how to update the DB? I mean, it's nobody is going to update the DB.
Nobody, but if you want to change, you can change.
Just change on it.
Change on the DB.
So this DB, you start, you will not change anything on the DB.
No.
Unless you change the
Value or reset the PLC, then it will go back to zero.
reset the PLC.
Yes. Okay, I will show you. On monitor. No, click monitor. Can you see? The 10 seconds is there, right? Okay. Start value, of course, zero because it's zero, right? But the earlier monitor value, the value inside was 10 seconds. Okay? Okay, now, if you want to change, actually you can do change here and also can download. Okay? You click here, you key in 15 seconds. T hashtag 15 seconds. Then you key in there.
Key what?
Key in, T hashtag 15 seconds. Let's say I want to change the timer value.
T hashtag
15 seconds.
15 seconds.
Yes.
So save it.
I can click here.
Okay, what?
No, this one. Yeah. Okay, can you see load start value as the actual value? Click here. Yes. Okay. Can you see it become 15 seconds?
Okay.
Okay, means you can manually change the DB values.
So if I want to change anything in the DB, I have to have a logic, or it is from HMI to edit the value inside here.
Yes. Okay.
I cannot do anything to there is no easy way which is not supposed to be, to have any easy way to reset everything in DB.
Okay. You.
This is this
Yes.
database is really a real memory.
Yeah. Okay, go to the OB1.
OB1.
Okay. You bring this one, the CPU make it bigger. Can you see? Memory reset. Click that. Reset the module, user data, needed, exiting connection, yes. Okay, you stop first. Just click yes. Okay, go online again. This one, no, this one, make it smaller. This window. Okay, monitor again. Custom, but cut off the, then run again. No, you run, because when you set this out, it stop and reset. Okay, your value become 0.
Because I key in 0.
Yes.
Okay.
But of course, because it's the start value is there, right? That's why forget to delete the start value.
Yeah, here.
Yeah.
So
The start
there's a
value is there. So
there's a conflict here.
because just now we changed the start value. If you didn't change the start value, because why 15 is still there? I reset the D. But in the DB, the start value I put not 0, 15. So that's why the 15 is there. You must take out this 15 change back to 0, then only.
I get what you say, but it's conflicting. It's conflicting.
Not conflict, because just now it's supposed not to change this, that's why.
Oh.
It's not, it's just depend when you want to change, then only we can change. But just now reset the memory, we will go back to everything 0. All the values.
Yeah, I try to understand
The concept here.
the concept here. Yeah. We have a DB. I say that DB, I understand what you say. For example, function block, right? They say that the function block, it can be a local DB or global DB.
Yes.
Up to you.
Yes.
Which is essentially is you want to share the memory with the global, or you will just want to have a DB that only use this function block.
Yes, correct.
Let's say both also can be done. Let's say it's a local, just say local DB.
Yep.
When you set the variable inside the DB, you have all the start value. Meaning to say when the CPU is started, then if there is no intervention from outside, this DB has a list of variable inside, and this is a default value. Default value inside. If there is nobody going to touch it, when you initiate it, immediately it will become this value stored inside. Then this DB is to be edited by the function block.
Yes, correct.
To be edited by the function block. So when I start, I have a timer in. It originally initiated as 15 seconds. Then at the same time, my timer, my OV here, I have a manual input of 0 seconds. So it should be in the end, after started, energized, then immediately it changed from 15 seconds to 0 seconds.
If here I put 0 second,
Just now here I put 0 seconds, yes.
Yes, if just now I didn't put anything, I just delete.
Okay, if you just delete, it will remain 15 seconds.
Follow the DB value.
Follow DB value.
Yes.
But if I manually have a manual input from the function block,
Then follow the function block value.
so when it start, it will be from 15 immediately change to 0.
Yeah, of course.
Okay, got it.
Yes.
Yeah. So essentially, this is a start value of, consider like a start value of the, well, this is a false value. It's not called.
It's a what? It's the initial status lah.
Initial status.
Yes.
When I start this function block,
The
this is the initial status.
Yes. It's false, and also It's depend on this button now.
Okay, so if I have defined a button, if I have defined an input, then it will start with a false, but immediately it will check what is the button
Yes, button.
status.
Yes.
If I don't define an input, then it will just start with whatever I given manual input here,
Yes, correct.
which is in this case is a false.
Yes.
So okay.
Currently it's depend on this button.
Okay.
If I remove the button here, it will follow what is the default value in your DB.
Okay, you will choose either one.
Yes.
If I have defined the automatic, not the self, I have defined the source for it,
Yes.
you will follow the source.
Follow the source. Yes. If I don't have the source,
then it follow the manual input.
yes.
Okay, I will just get the concept first.
Yes.
Yeah.
Okay. So this is the advantage of DB,
DB.
which is not in the FC.
Actually, don't have a DB.
Yeah,
It
don't
just
have the
follow a
DB.
fixed.
Yes, follow the fixed data.
Yeah. Okay.
Okay. So that's why the function block they use like this as a block.
Right.
So the FC normally like this is subroutine, or
Subroutine.
they want to use this can, but if I don't want to store the values, I can use
Okay. Okay.
that's all. That's a different actually, the main difference. If you want to store value, use function block. If you don't want to store value, use FC.
Sounds like F is a DB is a function block. It's for a little bit more advanced controller.
Yeah, if you want to save data,
You know, like some sort of set point or
set
whatever.
points, yes.
Simple control, then just use the FC again.
Enough.
Okay. Yeah, good for this.
Okay, just save this one.
Save.
Yes. Okay, now what we do inside here is okay. Go offline.
Okay.
Okay. Function block. Okay, you add new block. Add new block. Let's see. Okay, click here. I just want to use FC right now. Okay, max function.
MATH.
Yeah, max there.
Okay.
Okay.
Okay. It's a function. It's a function.
Just a subroutine.
It's a
I
subroutine.
want to use as a subroutine.
Okay.
So what you do, you go to main OB1. Okay, just go down. Just call the SC here. Okay, this is subroutine. This is code block.
Right.
Got it? Okay. Now you go to the FC2. Okay, so we want to see some max function. Go to the max function here. So this is where we can learn the integer, double integer, real, everything. Okay. So
Right.
you just add. Okay. You double click here. So these are the data types I can use: integer, double integer, real, long real. Okay. Click some more. Then, if you see U is unsigned. Okay. All integers only, no word or double word. Why? Because like I said, integer is in decimal. Word and double word is in hexadecimal.
Okay.
Okay.
Oh, so yes. Alright. Thank you for that. Okay.
Okay, so just use integer first. Okay. So we can use, for now, memory, that we use just memory. So we haven't used any memory yet, right? So we can start with MW0. Actually, I can use constant number also.
Okay.
Like
Oh,
50,
okay.
30 also can use. Or I can use memory also.
Which is in this case is MW2, right?
Yes, correct.
Okay.
True.
Okay.
Then the output also must be MW lah. Correct.
Yes.
MW4. Okay. Rename, if you want to rename, can you just right click here.
Okay.
Right click at the empty space.
Oh.
Rename, so you can rename to all the three.
Oh.
So just rename like addition 1, ADD 1, ADD 2, ADD value. Or data 1, data 2.
Anything lah.
Anything. Data 1, data 2, data 3.
Okay.
So can
Since this is just say it's count lah. Count. One. Or you want to
any name. Make sure you understand.
Okay. Count. Two. Count. Okay. Okay, something like this.
Yes.
Okay.
Okay. Save download.
Six.
Okay, monitor. You just key some values there.
From the data block. Oh.
No, just key in some values here itself because no data block here.
Oh, okay. Okay. Keep on scanning and keep on updating.
Keep on updating up because there's no interlock in front.
Okay.
I have an interlock here, then it will similar lah. Okay, when it's enabled, then only can count.
Oh.
When it's not enabled, it won't count.
This EN power is not in the black color. Any meaning? Okay.
No.
No meaning. Okay.
Make sure this one can see the color that is.
Okay.
Okay, now to try to put bigger values and see whatever.
Okay.
Cannot.
Okay. So there is a limit because it's a 65536, is it? Maximum.
Okay. Cannot also. Right?
Okay.
Okay, why? Because integer means it's a positive negative.
Oh.
So 32,000 maximum.
Okay.
If it is unsigned integer, then only it's a 65,000.
Okay. So integer is a bad, not to say bad.
Yeah.
It's a very limited. Okay.
Yes.
Unsigned integer. Unsigned. But I cannot change here. I have to do.
What? Want to change to unsigned integer?
Right.
Okay, can. You go off, but need to go offline.
Okay.
Go offline. You change this to unsigned integer first. Okay. UIMDB. When you change input, you see there's a box.
Right.
Okay, you see the box is what? So it shows what? Implicit conversion from integer to uninteger, unsigned integer. Runtime errors are possible. Okay, why? Because you put here unsigned integer. Here you put integers. So because this one all need to change. Unless the value within the integer it still can accept. It's above the integer then cannot. Okay, so how to change? You right click here. Rewire. Rename means name lah. Rewire means you can change the address and data type. So data type you change to unsigned integer.
Which is double.
Yes.
It is MWD. MW.
Still MW because it's still integer, 6 digit bit. But the only the data type become unsigned integer.
When we unsigned, the range is very defined 0 to 65,000.
No negative value.
No negative value.
Yes.
But you see, in the there could be integer, but a lot of time, we receive a lot of analog signal, right?
Mm-hmm.
And we receive a lot of things like, what is a Kelvin, what is the weight of the powder, a lot of this kind of stuff. This is considered as MD. It's a considered as
No. Okay. First, 4 to 20 analog will be integer. No, it's a still a W.
It's still a W.
Still a W, but it's a IW lah input. 4 to 20.
Actually, this is I think it's a very important thing.
Yeah.
The concept is straightforward, but just about imagine there could be a program, something to do with very complicated calculation.
Okay.
For example, you have a multiple signal sensor, flow meter, rate, something. Probably you have to calculate concentration. Probably you have to calculate the energy flow. You have to calculate a lot of the calculation, the formula is not straightforward. It's not a plus minus. It has to do a lot of complicated formula.
I know where
what
you are.
What are we going to do here?
Then must use real.
Floating
point.
Okay, then it's not a simple this variable can do. We must use real
data.
Real data.
Real data.
Okay.
So that's what you are looking for, right? Because whenever you do a complicated calculation, of course it will have a decimal point number.
Right.
So when it's involve decimal point number, then it must use real.
Okay. Not even double word is a call.
Yes, you cannot use double word also. Because double word or double integer is a decimal. It's still a decimal, but you don't have decimal point. Okay, decimal point is in floating point.
Okay.
So must use the floating point data type. So floating point data type is a real.
But very rare people do this.
No.
Must use.
Common. Real is common.
Real is common.
Yeah, of course. Because if you want to divide something from smaller number divide bigger number, of course you will get the decimal point number. Right. So of course you will use real.
Of course we use. So it's very common. Anything the control is related to a decimal, then
yes, real.
we use real.
Yes, correct.
Simple answer. Okay, got it. Yeah.
Okay. So now you leaving integer lah, indirect integer.
Okay.
You know me, integer, change to integer.
Okay.
We do a few, then we can know. Okay. So if let's say the number is bigger, I still integer, but the number is bigger, more than 32,000, and I have a negative positive value, I can go for double integer. Okay, so you take one more addition.
Addition is a calculation. Instruction.
Yes. Take addition. Actually, got so many things, not only subtract. This one calculate is a formula. You can add straight away the formula there.
And this is using programming already.
Yeah.
Okay.
Formula, then this one go down.
Can you do a programming like a calculation with a real?
Yeah, that's what I want to do.
Okay.
And another one, I can show you using SCL programming.
Okay.
Using SCL calculation using SCL programming. Because calculation with SCL programming is straightforward.
Okay. Yeah, sounds like real programming. Just like
Yeah, real programming is just one simple one.
right.
Okay, this one use double integer. Double integer. Okay. So when double integer involved, so because why I don't want to delete this one. Later on when you refer, so you can understand lah, right? That's right. Okay. Because later when you see, I delete this one, I just put real means what you thought. You only can use real. That's why.
Okay, okay.
I just want to use a few.
Got it, okay.
So must use MD. Correct.
Okay.
So
Yes.
what number MD I can use?
So now I use until MW4 already. 4, 5, 6, 7. 4, 5 is used up.
Yes.
So I have to use 7.
6.
4, 5, yes, 6.
MD 6.
Okay.
So next one.
And then 1 is using 4. So 6, 7, 8, 9, and D10.
Yes, correct. Actually you can involve in programming. No, if you do, I mean you practice, right?
Yeah.
No, not like big programs lah, like a simple programming, troubleshooting.
Like do the program yourself, right?
Yeah, actually you can do some ceremony so you can really.
If I have a project, I do the program by myself. Yeah.
Not only project, Say because you sure you will have some networks, your friends working in this company, some networks, right? So whenever they have some troubleshooting, so if you have the software, you go and get troubleshoot for them. Can do also side income. MB14.
That is a good point, really.
Yes,
Yeah.
yes, really. Why you want to waste your knowledge? Because you just want to do some troubleshooting, not going to do some big program, okay? You just troubleshooting. So your friends at some company, they are working in the company, right? And you just tell them, okay, I have basic Siemens knowledge. If you have simple
I
troubleshooting,
can
if you want to
review your code or something.
yeah, I give you a code. Of course, you want to call your vendor, of course, you charge. Very expensive, PLC.
The chance of vendor to come to do service.
Yes. One time they only charge because that's what we struggle here. Because we are not machine makers. Okay, so sometimes the company call us normally small companies. Because big companies they only call their vendors. So whenever we charge one time come and see me, we charge 800 also on the client to pay. But in Kerala, just want to come and see me, 2,000 to 3,000.
I know the price.
Mm.
Yeah. It's a few
Sometimes-
thousand for one day.
Sometimes more than that also.
Right.
If I solve, it's different price. Yes.
But of course, this vendor they are coming, just like you said, they are representing the company. Anything goes wrong, they are
Yes.
accountable.
Yes. Because they are vendors, right? So
Right.
they are the most know that. Even offshore all very, offshore last time I one participant told me, offshore one time come 16,000.
16 for
16.
one trip.
One day.
One day.
One day.
Wow.
So if let's say this is at another day, the second day will be 10,000.
That is the best part. Yeah.
Yeah.
Okay.
In Singapore I think the offer is good. Last time I went for my friend's company, they offered me how much? 6K.
6K one day.
No. I mean, but it's a automation engineer
Oh, you mean in Singapore?
in Singapore lah.
Ah.
6K, but your side all, I think you can earn more than that on project side lah. If you handling projects, all that. I know last time I have one guy come here. He work in Singapore, but the company is in Singapore company, but their client all in Saudi.
Okay.
So you go there and do commissioning. Is more to project management lah. Like you also project management, right?
Right,
So
right.
you also more project. So you have a project. So you see, Singapore dollar monthly and 10 plus.
Provided that is in the oil and gas.
Yes.
Provided that is in oil and gas.
It's an oil and gas company. Okay.
That's true. Okay.
MD14 oil and gas, good money.
Yes, definitely.
Another thing, you can
Okay.
do MD14. Another thing, oil and gas, they use your machines, right? All the machine, they don't buy the machine. I'm not sure maybe you heard before. All the machines they use, it's not buy, they buy. They rent.
You mean for the commissioning?
No, they rent the machine.
For the offshore,
offshore.
where they build inside.
Yes. Let's say the cabin they use. Of course, like cabin they will normally rent lah. They rent.
You mean they hook up inside or
Yeah.
not the one hook up inside?
Yes.
Like you do the F&G that is they buy right? Or
No, the main part. I mean, taking the oils, all of that particular machine. I'm not sure lah. Some other machines, some of the machines is
like
rent.
compressor, all this kind of thing.
Yes. There's last time I have one participant from Singapore. The second time come. Last time he come for Mitsubishi training. That day he come for Schneider training. He told me that now currently working in Saudi. So it's a chamber. It's like a pressurized chamber. So the diver will go down, do some welding, all that. Okay. So when the diver go down, okay, so the pressure will change, increase, right? The moment you go down, the pressure will increase. So this pressure chamber, what happen? It will, if you go down, the moment you go down, it will, according to your outside pressure, it will press inside. Okay, it will be neutralized.
Right.
Okay, then we go down, then only you release. The moment you release, your pressure and their pressure will be at the same level, so you won't feel anything. You go do the job. When you come back, you get into the chamber again. But the chamber very fast can go up, very fast can go up. The moment you go up, it will neutralize your pressure to the normal pressure. Okay. This machine is not their company one. One company is doing this services lah.
They outsource the service lah.
Yes,
the
this
service
company.
outsource, yeah.
And the machine they use is not their machine. It's rent.
Right.
You know what the guy said? Because he's very close to me. He said, "Why not this machine very easy lah?" Then he told me all that. He said, "I have all the documents. Why not you build the machine, use rent?" I said, "I can do program me. I don't have manpower to do the machine, to do that." I said, "I can. If you want me to do, if you want to do that, you can do. I can help you in the programming part." He said most of the machines are all rental.
But I have a friend. Their company run the oil and gas subcontractor business. It's a very, how to say, of course definitely it's very lucrative. The profit margin is very high. I think the point is you see what they renting just like you say they're renting very simple thing renting welding machine, genset, of course sometimes crane, big and small. This kind of stuff is a very, just like I said, very frequently used by the oil and gas. It's it sounds like more makes sense they buy it themselves, but somehow they just outsource it to all the outside.
Yes.
It sounds like everyone can do this, right? If I buy a genset, I also can rent to you at a very, very high margin. But the difficult part is here. Difficult part is to get the company registered with the oil and gas.
Yes.
It is very, very hard.
Because they more on the concern on the what? Safety.
Yeah, yes.
Safety,
license. And then your
yes.
company financially have to be super strong, whatever.
Yes,
Not
because
everyone can register.
yes.
Yeah.
Then the safety. Then you have the manpower to go to that. So the manpower must have a certain certificate.
You have to prove yourself why your company is outbid the other vendor. Yeah, that is the part. To be honest, just like
Actually, it's good money. Oil and gas.
It's a very good money, definitely.
Yeah, good money. Because that's the thing. Because why the oil and gas don't want to buy this? Actually, genset only buy.
Right.
Actually, they can buy.
Right.
But why they want to buy? Because if I buy, I need to assign another engineer to maintain that.
Probably that is the case.
That's the main case.
Yeah.
So, if anything problem, it will take time to solve issues. So instead of that, I rent. So anything problem, I give to you, you will give another one.
Probably like
Yes.
something to do
Like
with
a car, like a car rental.
Yeah.
Right? If you have your own car, you do your own maintenance, everything.
Yeah.
If you rent a car, you just paying for the rental, use the car. Or if the car is not nice, then change the car. Similar concept.
Probably that's the case. Yeah. But then anyhow, oil and gas, definitely is a big one. Definitely.
Oil and gas
is a
big
big
one. I get a lot of but recently like last year, end of the last year, like from August to December, I think I get around 8 participants.
Ah.
All personal,
Ah.
8 participants, all from the oil and gas.
Personal.
All personal, oil and gas, offshore, ship.
Okay.
Because ships all still using PLC. Right?
Yeah.
Yeah,
All
because
the ship, like all this you do like oil and gas. Singapore has a lot of FPSO, right? These are all the ships FPSO. They all come here to learn PLC.
Not all, some companies. Like there's one company called Subsea. Subsea, IKM Subsea. They come here for the PLC. Because they one group lah. Other than that, all like personal from Singapore. Because that group is because they do what you know. They also doing something. Okay, if someone go and do welding, they have like a crane. Then that crane will be like a robotic arm something. It will go and hold like a camera.
Okay.
So from top you can see what it's doing and everything monitoring purpose.
Robotic control.
Yes, robotic control. But it's using PLC.
Oh.
It's not robotic arm.
Okay. It's not a robotic arm. So
Yes,
it uses a
just
PLC
a
to control
PLC
all the
control to
mechanical.
the rotation, all that movement, everything.
Or can be done.
Yes, of course.
Because robotic is very I don't know what's the difference but I
No,
feel
robotic
Yeah.
also have they also have a controller. Okay. But robotic is just a motor rotating one.
the scanning time is very high.
Yeah,
I
scanning
mean
time.
their frequency because they have to be very accurate, right?
Yeah, very
You cannot
accurate.
check a little bit.
Can I shift it a bit? Okay.
Yeah.
So what happened? PLC also can control the motor.
Capable until
Capable, yes. You just do the programming only. But what happened is they for robotic they have their own controller.
Yes.
But it's not like a controller, like just a PCB lah. So they already connected all the motors, everything connected. So you just need to tell the robot, okay, where to go. So this position. Then robot and PLC can communicate using Modbus also can, or just a normal hardwire also can.
Hardwire also.
Nowadays robot very intelligent really. You don't need to do the coding.
Use the software you mean.
Yeah, you use the software, no need to do the
Right.
coding means you just need to tell the position, which position you want to go.
You just move to here.
Move to here.
Save the position.
Yes. Nowadays just bring, okay, save.
Yeah.
Bring here, just save. Then they call something teach, I forget.
Teach. Yeah.
Teach. There's a something teach in front of them. So
Yeah.
it will just then once done, the coding will be there. So you want more accurate, just go and adjust in the coding. That's all they can do the job.
Sounds like anyone can commission a robotic arm already.
Yeah, but the thing is you need to know the how to use the software. Nowadays very simple. Everything software nowadays now you use the software only. You need to know how to use the software. That's all.
Okay, yeah.
Okay.
Yeah.
Okay,
Okay.
try one. MD 14.
And so this is a
Okay, you wrong already, right? Okay, never mind. Right click, rewire. The MD1, you change to MD. You see, because MD1, right? See,
Yes.
is clash with this, all this, right?
Yes.
Clash with MW0, 2, and here also.
Yes.
But can you see no error?
No error.
Yes. So just put 14.
So sometimes it really learn how out of the error.
Because it can be used that way, that's the thing.
Or can be used that way.
Yes.
People sometimes do this also.
Can use because it's let's say because double word, right? It's two word. So, okay, let's say, okay, good question actually. Sometime, when you want to take data from, okay, this is the one example, but I forget already where to use. This is just an example, lah. Okay, now you are using one drive, okay, using one drive, and you want to read the IP address of the drive. For example,
Okay.
using Modbus,
Right.
for example. Okay. Then what you already get the value already lah. Okay, let's say it's in double word. Cannot be double integer, can be double word. Okay, 4 bytes. So let's say MD10. Okay, this is where. So you don't think about how we take the data. Okay, the data is already here.
Okay.
Okay. Now how we want to read the IP address. Now MD10 we already get ready. MD10 got 4 bytes. So inside MB10, MB11, MB12, MB13. 4 bytes. This is where you get the IP address 192.168.0.10. So it's the same program. You can use this and also use this. You get the data here first. From here I get this data. Or sometime what happen? Okay. Another one. Okay. Sometime like you want to read some values from the drives or like that. They will tell it's a double word. MD10 for example. And in the manual, when you open the manual, they say okay, this value is double word. And upper value is like what term they use? I forget it. Upper value and lower value lah, just like that. Okay? Upper value, lower value. So upper value means it's the torque, for example, the motor torque. The lower value is the the torque and the current, the load. For example, if you want to read something, this is all for example.
Okay. Example.
So in the manual they will tell okay, this is one double word, but upper value is so upper value means MWC and MW. So here you will read the torque value. Here you will read the load value.
This double word or double word or word or mainly a double word and word.
Double word and word.
This concept is it standardized among
No.
industry? Because just now you say this also happens to be can be like from a vendor.
Oh, you mean the word double word?
Yes.
Yeah, of course.
It's standardized.
Standard, all the drives, all the device, instrument, all that.
Control automation, everyone using this
Same thing.
double word and
Double word and word. More common is word lah.
more common is
Common
word.
is 16-bit.
Oh.
Common is sometimes they use 32-bit too.
Because just now you say like M10 is a IP address, right?
Yes.
I try to understand. You said like everyone, every brand, every vendor, they will standardize IP address. I'm giving out. I always giving out in a double word.
Yeah, if let's say it can give you IP address, must be double word.
They will always standardize. It's a double word.
Must not
Must
specified.
be.
Must be because why? I have 4 value.
Because you have 4 values.
Yes.
So, okay. And each of it is a MD.
Yes.
Oh,
So byte values. Or even it's depend because why?
But you
Siemens
see,
have byte.
you see, just now you say the MD. What's the range of MD?
0 to 255.
255.
Yes.
MD is 0 to 255.
Yes, 8-bit.
Okay. And the double word is hexa. No.
No, not hexa.
Then double word is what is it?
Word. Okay, very simple now.
I just tried. Okay, wait. The question is actually I'm having is this.
Yes.
I take a value from this
Drive.
this drive. I receive a value. I assume let me say 255, 255, 255, 0. So there is a hexa.
No, it's a decimal.
Decimal.
Yeah, decimal 255.
Okay,
In extra is
decimal.
FF.
Okay, 255 decimal then.
Yeah.
So it's a 255, 255, 255, 0. and then I go to the PLC, I retrieve this value as a double word.
Yes.
So I want to display this double word directly in HMI. I just say that I don't do any processing.
Okay.
What I will read.
Yes.
Yeah.
So what you will read? Okay, you go to calculator. I will tell you. Okay. So go to binary. So let's say it's 255, 255, 250, right?
Yes.
Okay. So what do you do?
So I have multiple seats. There's a lot of seats inside. It's a 10, 10, 10 inside.
So 255, it means all 8 bit is 1111. Okay?
Okay. So it's
I'm putting
111, 111,
yes.
111,
So that's it. So this is all 1111, right? But
you say this 255 now is a decimal. It's a decimal, right? It's a 0 to 9, 0 to 10.
yeah, the decimal number, normal number. Yes.
Normal number. So if I
If
want
I
to read it as a double word, you have to convert back to the binary and then make a long string of binary and then convert
Then
back to
only you
the
can get the
decimal
value.
again.
Yes. You just put 11111 24 times. Okay. So the first byte. Okay.
Then 24 times. This is
No. Actually, yeah, you must put 0008 first because this is 0000.
okay. But this is the last string.
Last string, but for Siemens, this is the first byte.
Okay. You
You
always
know
come
when
from the
I
last
do
to
the
first.
yes, when I do the branch, right? When I do the branch, remember
Very
MB10.
programming.
Yes. Okay. This is MB10, MB11, MB12, but this is for Siemens. Others normal lah. Okay. So this is one, right? So inside here I got 8 bit, correct one. So same until here, right? Okay. So if you want to read, the first bit is here, the bit number 32 is here. This is how you read.
Okay, just have to know that Siemens always read from the last to the first.
Yes.
Okay, so if I have a set of this
Word or double word?
word or double word 255, 255, 255, 0, then if you read and combine it into a double word, if you read from the last 0,
Yes.
255, 255, 255.
Yes.
Okay, and for 0 in the binary, for this byte, this is the byte, right?
Yes, correct.
Is 0, 0, 0, 0,
Yes.
4 number of 0.
8 number.
Oh, 8 number of 0.
Yeah, byte is 8 bit.
Oh, 5 is 8 bit.
Yes.
Okay, so it's a 0, 0, 0, 8, 0, and then the next one is 8 1s.
Yes.
So it's I have to key in total of
Yeah, all these 0, the rest is 1, 1, 1, 1.
12 number of 1.
No, 8, 24.
24, okay, 24 number of 1.
So 0, 8, 0. No, 0 first.
But I cannot key in 0.
Okay, then you just put 24. 24 1. Then you
Okay.
have, yeah. 8, 16, another 8.
Okay, there's a 24 1.
So this is the number. Can you see? FF,
In half is the FF.
FF, 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 0. Last number, of course, I can see.
Okay.
So in decimal is 16 million.
So if I retrieve it as a double word, I will read 16
16
million.
million, or in hexadecimal means you will read FF. In binary means you will read this B. So you need to make the double word into 4 bytes.
Okay.
Read as 4 bytes, then only you can get it.
Okay. I know the concept. Okay.
Yes.
Yeah.
So this one is just an example.
Okay.
I
Okay.
never done this before.
But At least this is how the internal will be.
Yes, that's how it works.
Okay, got it.
Or sometimes what happens, because only some PLC only have bytes. Some PLC straight away word.
Okay.
So what happens? They will give like two words. One word for one number.
Right.
Okay, one word. I mean 4 words lah. So they will use 2 double words to store the value. So they will put like okay, let's say for Mitsubishi for example. So they will tell okay, D0 and D2. So D0 and 1 is the first one. D2 and D3 is the 4. Because that one don't have the values I want to store value don't have bytes. Straight away word. Some PLC straight away word don't have bytes. Siemens they have bytes.
Okay, yeah. I will understand it first.
Yes, but no problem. Once you understand this concept, then when you want to do something retrieve, of course you will follow the manual. Right. So when you go into manual, you can understand it.
Okay, yeah. Get it.
Now what we do? This one okay, I will know. I want to, before we go for lunch, go down. No, you just take anything lah, multiply, divide lah better.
Okay.
Take and put it second. I want to use real.
Okay.
Yes. Use real. Real and wrong real simple. Real is 32-bit. Still must use MD, yeah.
Okay.
Long real also is a 64-bit.
Okay.
So must use MD also. But it must use 8 bytes in different lah. But normally we use real only.
Okay.
What's the difference between real and long real? Real can give you PLC can read up to 7 decimal points. Long real can go up to 15 decimal points.
When you say decimal point,
After the point, after the decimal.
After the point.
Yeah,
In
because
front,
in front is very
also
big.
can.
Very big.
Oh.
The real value is only real negative 3.4 times 10 to the power of 38.
Oh.
And 3.4 times 10.
There's a branch for it.
Yes.
And then the digit is just like the 7.
Yeah, so 7 decimal point you can get.
So really this
Very
is
big lah.
good enough already lah.
Yeah, of course.
Okay.
Okay. So this one must use MD, MD. So what MD is now until 14. So put some number here. MD 18.
Okay.
Similar like double word, they use the same addressing type. Because
As a double word.
yes, why both using 32-bit of data.
Okay. So I MD 18 already. So this is plus 4 lah, MD 2 lah.
Yes.
It can store so big value, but the length of the bits stands empty.
Yes. The length is 32-bit, but you can store bigger values compared to the double integer. The double integer can go up to 4 billion only maximum.
Right. Okay. So this is how it is MD 26. Okay.
Okay, now down to address.
all is running.
Mm.
Of course, this is not getting any value, but I can add.
So that one you can add maximum bigger numbers 60,000 plus 60,000.
This is really a long number. Negative. Cannot too long.
Yeah, maximum billion, more than billion. Okay,
And this one is no limit.
no limit, yeah.
Almost no limit lah.
Almost 30 numbers.
Okay. Okay. So this is a simple calculation for division.
Yes.
Okay. So in all the analog is using real, is it?
No,
No.
not all. Analog means, 4 to 20 or 0 to 10 is
Right.
is an integer.
Okay.
If it is temperature, it's real.
But if you receive a signal, you must receive it like 4.61 milliamp. It cannot be 4 milliamp. Immediately jump to 5 milliamp.
Yeah, but in the PLC, you won't get 4 milliamp. In the PLC, it's different value. So,
Okay.
just for your, maybe because I think, later finish, I think today maybe I will touch on the analog model.
Okay.
Because we're almost there, so we can touch analog model. What happens is, when you give 4 to 20, in the PLC, it will read as a 0 to 27648.
Okay. It's already scaled.
Already is a bigger number. It's a, they call engineering unit. Already an engineering number.
Okay.
From here later on we need to convert to the depend on the instrument.
When you open the PLC to read, you're not reading anything is 4.66 milliamp. You
No.
only can read something is like
Some value there.
some value there.
Yes. So with 4.66 million, of course there will be a value there.
Got your point. Okay. Here is how the PLC works. Okay.
Yes.
Yeah.
There's no PLC just straight away read milliamp. No. Of
Oh,
course
okay.
they must have some value.
Okay, I got it. Yeah. That's
Okay.
interesting. Okay, yeah.
Right.
Okay.
Then we can go for the break.
Okay.
Yeah.
Okay, so I come back 1:30. Alright, thank you.
So go by.
Okay.
It's not okay, huh? So you go offline. And bring it down. Go to instruction. You can use compute.
Calculate.
Yes.
Okay.
Sorry, compute is in assembly.
Oh, okay.
Yeah. So you can choose what is the data type. Okay, click that. What data type you want to use? Let's say real, normally common real. Okay. Then here you can put the inputs. How many inputs you want? Okay.
Is it all the time? All the instruction, all the math function. Your input and output must be the same data type. Your in is real, out is real. In is
Yes.
integer, out is integer.
But it can be this way, like this, right? The input can be integer, but the output must be real.
Must be.
Ah,
Or you mean? I mean, let's say in this case, the division. I can use.
cannot.
Yes.
Must use real.
Must use real as well.
Real. Elementary can.
Okay, got it. Yeah.
Elementary. Others, some PLC can, but Siemens cannot. Real means real because if it is, that's why they have a function called convert function.
One data type convert to another.
Yes. So let's say you want to do some calculation. You receive is integer, but the calculation need real. So you need to convert to real first, then you use the real to do the calculation.
Normally, it's what people do is this.
Yeah, this is the way,
real,
yes.
and real calculate.
Yes.
Okay, got it, got it.
Okay. So here is the output. Okay. Here you put MD30. 30, new one. Or you can use the MD26 also. Okay. Then you can put a constant number. 2.0, 3.0, any number. Okay, must put 0.0 lah because real. Okay.
Okay.
Okay. Then here, you can add another one. Okay. So let's say this is MD30. Okay, you tap. Then output.
So okay. So output is.
You double click here. So this is the output. Okay, this is where we do the calculation lah. Okay, close first. Okay, here you put the output MD34. Okay. So this is where we do the calculation.
Right.
Okay, how to do the calculation? You click here. Okay, you bring it up a bit. So you must use the in this name to do the calculation. Can you see the example? You must use these names. It's like a function block lah actually.
IN1, IN2,
IN2, yes. So let's say you put bracket, put bracket, IN1 multiply IN2, close bracket, divide IN3. Okay.
keep on scaling and updating.
Yes, constantly depend on this calculate, multiply with this one, the value divide, here we get the value.
And this way of writing a formula is just as similar as to Excel lah. How you type a formula.
Yeah, in that sense.
How about curious? Just curious. Of course, I'm trying to imagine that more complicated situation, but normally wouldn't go to that complicated. There could be some function. It has like at least 20-30 parameters.
Want to add, you mean?
Right, a lot of temperature sensor go in. I just give a
Then
very
you must
case,
add.
yeah. Like some process plant, they definitely have this.
Of
They
course.
calculate heat loss, and then you have a lot of flow meter, a lot of sensor, a lot of
So in that case, okay, let's say how to calculate it.
a very complex formula.
Okay, so you must separate the formula lah.
If you either is you use a programming, something like a programming,
Yeah, that is called structure. Yeah, and you can use the SCL programming.
can
Okay.
within the block you use the SCL.
Yes.
So it's more than a simple one line formula.
Yes.
But you have so your SEL can consist of what? Can consist even of like
Many
if, then,
items.
anything also can. All
Many
the
items.
programming logic also can.
Yes.
Or not only formula lah.
What about formula? So let's say okay, you first you add all the flow value.
For example, yeah.
Yeah, so let's say 10 kilometer. Okay, you want to find the average plus all, okay, divide into one line.
Right.
Then after that
Set
you get the
store it as
value.
a variable A, and
Yes.
then from this one you repeat,
Yes.
loop it probably store
Yes.
as variable B.
Okay.
And yeah, two things. You can do a complex programming
Yes.
inside the block.
Inside the block, okay.
Oh, okay, got it.
But can use SCL also lah. Right.
Okay. Just to understand how far I
Yeah.
can do it.
Okay.
Yeah.
We go to add new block. This one you know right how it
Yeah,
works.
I think I understand how it works here.
Okay.
It's essentially all the calculation is in out. Yeah.
Yeah, just so no need to test. Okay. Go to add new block. Okay. I want to use FC lah.
Okay.
Because
Let's see.
yeah, but I don't want to keep any values.
Okay. So that is not using a math function already. Not using.
No, I'm creating my own. I want to use I'm not using ladder programming. I want to use structure
So
control
must use
language.
Okay.
SCL.
FC.
FC also can, FP also can. But I want to use FC because I don't want to save data. Just want to do some calculation only.
Okay.
SCL, okay. So you just put calculation. Okay, then. Okay. Here you put a few inputs.
Okay. Randomly, I just randomly I just see one.
F1, okay.
Then
No, wait. You
Okay.
open this. You make it real first. Okay, type. You can type also.
Oh. Okay.
Okay, then you click here. Okay, you drag. No, you can add more.
Oh. Okay.
Okay, enough.
Yeah. Enough.
Then output.
Okay.
What's that one output lah, right?
Okay.
Okay.
Heat loss just randomly.
It was okay.
Okay.
Real.
Video also. Okay.
Okay, good. Now, first. Now, like normal programming you can do. So, but the output first lah. The output is what? Heat loss.
Right.
No need. That one no need. If then or no need.
Okay.
Just put heat loss. The heat loss.
Okay.
Okay, heat loss. This one. Okay, equal. Semicolon equal.
Semicolon equal.
Yeah.
Okay.
Not sorry. Colon equal. Okay.
Which one?
The two dot.
Two dot. Oh.
Yeah.
Okay.
Okay, equal. Okay, open bracket.
Open bracket. This one.
No, open bracket.
Oh.
Yeah. Okay. So what is the formula?
Okay. we start with simple first, just say temp. But now this is like a one line item, right? So for instance, if there is a more complicated condition run inside, for example, there's a loop.
Okay, never mind. What I do?
Yeah, if it's a
Okay.
looping or if there's a condition, if then this kind of
Can
thing.
also.
Okay.
If the temperature is this, then it
Then you
calculates
use this
this.
value.
Yes,
Yeah.
it can also. It's just how you want to program here.
Okay.
Ah,
So this is following a programming.
yes.
This SCL language is
It's just a SL language, like easy to
it's
do
a
programming.
Siemens language lah. It's
Yeah,
not a-
no. Yeah, it's a Siemens language. It's not computer programming lah. Okay, but similar to the C programming. C
Similar to
that
C
has,
programming.
yes,
Yeah.
you can use. Other PLC they call, actually this the common name is structured text programming. Other PLCs all use the name structured text. Only Siemens they call structured control language. It's the same thing.
Like Omron.
Omron,
SHRD.
usually they call structured text.
Are they have the
Similar.
same language or syntax? Like exactly the same you
Yeah,
use
it's
here.
same.
Elaborately also
Use the same syntax.
same syntax.
Yes.
Oh, okay.
Okay.
So I
No,
simple
I don't
one
want
first,
to
yeah.
do this one. Okay. You delete.
Oh,
You add here. What I want to do, I have how many temperature?
7.
Okay. You add a temporary.
Okay. Any name, whatever. Yeah.
Just put data 1, data 2.
Data 1,
Data 2.
data 2.
Okay. Make it real.
Okay, everything must be real first.
Yes.
Okay.
Okay. Close. Okay. First data 1. You put the data 1. Data 1.
Okay.
Okay. Equal to. Two dot equal. Open bracket. Temperature 1 plus temperature 2
Okay.
plus temp 2.
Okay.
Okay. Close bracket.
Close bracket.
Divide 2, for example.
Okay. So, for example, this is our programming language calculation inside.
Yes. Then semicolon.
So, okay, must use a must close
Yes.
line.
Close. Okay. So these two plus. Okay. Then second one. Data 2. For example, data 2. Okay. Same lah. Equal. 2 dot equal. Open bracket. Temperature 3. Temperature 3. Okay. Example lah. Plus temperature 4. Okay. Divide temperature 5.
Okay.
For example. Okay. Close bracket. Okay. Then last one is the heat loss.
Okay.
Okay. Okay. Data 1 multiply data 2.
Okay. Okay.
2. I mean, you can put in bracket
Oh, okay, must. Okay.
because I want to. That's based on calculation. Okay. Put open bracket, close bracket. Okay. Okay. Divide.
Okay.
Then open bracket. Just put temperature 6 and temperature 7.
Okay.
Plus temperature 7. Yeah.
Okay.
Okay. Alright. Okay. So let's say that it's a big calculation. Okay.
But assume this is a big
Big
calculation.
calculation.
Okay.
So we don't care lah. Just wanna make it simple lah. Okay.
Right,
So
right.
like that. But I have only 7 temperature and 1 heat loss.
Yes.
Alright.
Yes.
But the formula is I need the temporary. That's why I use the data 1, data 2.
Temporary, yes, yes. This is a temporary variable.
Calculate first. If
Yes.
no, I can put in that all that into one calculation also can. Correct? Or not?
I got your point.
So but I'm separate the data.
Okay.
Okay. That.
Essentially, this is a FC. FP, everything. This is a declaration.
Yes.
Okay.
What do you want? What is the input I have? inside the block only, local tag,
Okay.
local variables.
Okay.
This is the input variable, this is output variable.
Okay.
Go to main,
Okay. So I now I put
then just take the block 3, put it here then. Yes. Now you put all the temperature data here. All the analog values here. For example.
Okay. See.
But actual means all will be the memory.
Sorry.
In actual situation, all will be the memory or DB. Because temperature is always keep on changing. Now what you're doing is you are giving a constant number.
Right.
But then when we do this way, because if no means now all the 7 value we have to key in.
From the
Analog,
analog,
we do the scaling.
it always convert to dB. No,
No, DB also can, memory also can.
memory also can.
DB also can.
Okay.
It's up to you. That memory or DB you put it here. Then only
Okay.
you will get the heat loss. So heat loss, of course I must use MD. What MD is available?
He lost. Okay. So just now we have used up so many.
We don't know. What we do, we go to PLC tag.
Yes. You mean here?
Yeah.
Okay.
Show all tag. Okay. Press the yeah. So which one is available? 38.
Total 38.
Yes.
Here we have the OP. This is and the 38. Okay, so if we run, we really need to show value.
Show
But the
value.
real situation is here you have to retrieve from either
Retrieve from an analog input.
analog input, which is after scanning is a M lah, it's a M.
Yes.
Okay. Okay. Okay.
Or you go to the block. Yes. Instead of using the input output, I can directly here use the tag.
From here.
No, instead of okay, then when you click here. Okay. What if you go to show all tag? You create 3 tags. Pressure 1, pressure 2, total pressure, for example.
Okay. Pressure 1.
Okay, let it be real, correct?
Pressure
2, total pressure.
Okay. Okay. Pressure. Okay.
Okay. Now go to the block. Yes. So all this we use the internal, right?
Yes.
Then later on we call is that, right?
Yes.
Or you can just straight away use the text also, okay?
Like I have to use a.
Yeah, what you do, then you delete this one. Okay, you click here. You go in front. Yeah, just enter. Okay, then you put it here, the 2 slash. Put 2 slash. You can put comment. So you put internal tags.
Or import. Internal
Tags.
tab.
Internal tags or variables.
Okay.
Which one you understand? Okay.
Okay.
Then here is the PLC tags. Okay. Now that one can delete. Now you put the pressure total equal to pressure 1 plus pressure 2. I'm
So I
using
have to use a.
the PLC tag I created. No need that one.
No need
Just
that
put
one.
the pressure, the name. Yes. Pressure total. Oh, total pressure. Ini okay. Okay. Block 1. Pressure total. Okay. One plus pressure.
Okay. And
This is
then
a liquid. Yes, that's all. But this calculation, because I'm straight away give the tag here already.
Yeah.
This one, because this is similar to like the subroutine lah. This is subroutine program, this is code block program. So you can see the difference. Subroutine program, I straight away use the tagging. Right?
Okay. So if I go to see the block here, not even need.
It won't show you, it won't show the pressures.
Yeah, it won't show the pressure here.
Because why? Because all these R's I list down in my
In out.
in out. If I'm not using also can
Interesting, because both also actually doing the same thing actually.
do the same thing. One is I created because maybe I want to use multiple time.
Okay, okay.
One is I just straight away do the value there.
Yeah. Okay, okay. Okay, your point. So here if I do at the in out, I can still map it to different
Then I can
But that
use
one is
another one.
Right.
And I do the program and I lock it.
Right.
Also can. I can lock the FC.
Okay. But roughly okay. So there's a difference here.
Yes.
Got it. So and this is how theoretically if people do this then very likely he will choose to use a function block instead of function because it can store data and
Yes.
okay. Because normally just like say FC, the best place to use the FC is calling subroutine.
Yes. Calling use as a subroutine lah.
Okay. Use as a subroutine. Okay.
Or actually calculation also can. But if the value need to be stored, then of course I need to use the function block.
Okay. Keep this first. Okay.
Yes.
Yeah. Understand.
Okay. Good.
Okay. Good.
Any question until here?
No.
No,
No. Okay.
Okay. Now what we do? You save this one. Okay, we keep. Now we go to the analog program. Okay. So we don't disturb this program. You create new project.
Okay.
A3 analog.
Okay.
And this one we use this one, but this one maybe next week we use because it's a mini amp.
Okay.
This is a mini amp. You can see this is just a temperature controller. Number 15 and 16 you can see it's a mini amp.
Oh, this is a element itself.
Yes, it's a what? Thermocouple.
Wow, so hard to read.
Very small.
But how you know it's a million is a 15 and 16?
15 and 16 very small.
Oh, because 4 to 20.
Yes.
Plus and minus. Okay.
So this one measure and this one for 4 to 20.
Okay. Measure is the 11, 12. Oh, this?
Yes.
Actually, it's a 3 wire, is it?
2 wire if thermocouple, 3 wire is if it is RTD.
Oh, okay. Okay, so we have this, and then it's a 15, 16. So this is a 15, 16. One is plus, one is minus.
Yes.
And then we connect to
PLC. Okay. Now here cannot because this one is analog input is here, right?
Yes.
It's a voltage. You can see here they put AI is a voltage.
So your analog card, then voltage is for voltage analog card. Medium is for medium for analog card.
No. This building only is a voltage. If I use the additional card, it's a programmable.
Oh, I can choose.
Yes.
But built-in is a fixed.
Yeah, like
always,
this one inside here I got 8 AI and 4 AI. Both I choose. Milliamp also can, voltage also can.
Okay. Only an external card you can choose. Internal built-in.
Internet is already building, so that's you can use.
Okay. got
So
it.
like this also have a 5 analog input, right?
Yeah.
This one also is a you can see here. The first analog is voltage, second one is the milliamp, third one is the voltage, fourth one is the milliamp.
Okay, so that is how. Okay, initially, but actually this is voltage.
This is voltage. You can see here. Very small one.
Okay, 0 to 10 VDC.
Yes.
Okay.
So this one can connect here. So actually when we do PID, we connect here.
Okay.
Okay. So for now we can use this sequence injector.
Okay.
This one can inject put it here. This one is
Okay.
okay. So this one is a signal generator. Can generate for the milliamp. So what you do, this ground at 24, right? Ground at 24 you connect here. 24 volt, 0 volt.
Okay.
If no space, just loop it lah. Okay.
Okay.
Okay. Then this ground and voltage out. So this ground go to the 2M. 2M is the negative side. And this AVO is the positive. The positive go to the first input because we have a 2M, 0 and 1.
So for I/O, always have a COM.
Yes.
Okay. I mean, each device has their own COM.
Yes, com.
Okay. Okay.
Okay.
Okay.
To that, then
This is a power supply.
yes, 24 and ground is positive.
Power off. Class numbers, right?
The first one is the plus.
Counter, this function is also in the math, in the PLC, right?
Counter.
Yeah.
Yeah. I haven't touched the counter yet. Later.
Oh, okay.
Maybe next week. Yeah.
Okay.
Because when I go to counter, is out of not out of it. It's what?
Then
Very
people ask a lot of-
not very common
in PLC, people do automation.
common also lah. Depend
Just
on,
like you say, you count the portal also one of the very
yes.
common things
So
already.
that's why I say depend on the machine type.
Right. Count on the
Yeah.
belt length, everything.
Yes,
also.
but normally the flow meter is actually use pulse.
Huh?
Some flow meter is 4 to 20 milliamp or analog.
That is a good point. Okay.
Some flow meter is a pulse.
You mean like a totalizer?
Yes.
Like
So
count.
they have like give counter value, but it's a high speed counter. So for that I can't use the normal counter. I must use high speed counter, like an encoder, like you reading the encoder value.
Okay. Okay.
That's the thing here. Some of the instruments we don't have. If I have also, how to test? That's a problem. If you
But at
don't-
least you have a transmit. You have
That's
a
why temperature is easier.
Yeah.
That's why we have that. Actually, temperature I have a lot of temperature probes. I think
Okay.
more than 5 probes I have.
Okay.
Because easy to calculate, easy to measure.
Yes.
Like a pressure or flow, all that very difficult.
Okay. So now I go into AI. AI is
So you will have the ground go to the 2M.
okay. This is a coin. Use a 0.
Yes, the first one.
It gives you M01 as a one set. Any instrument can use up to like 3 wire at the I/O side.
What's that?
I mean, because you have M0 and 1, right?
Okay.
So is it like any
No, M01 because M0 is one input, M and 1 is another input because got two analog input. So both the analog input will share one M.
Okay. Okay, so it's both instrument is looking back to the same place.
Yes, but if you use additional cut like this, always you have two. One is M, one negative, one positive, one negative, one positive.
Oh, always separate.
Always
this one is
two.
shared.
Only this particular this one is the negative one is the share.
Oh. Okay, got it.
Because by is a voltage.
Oh, voltage
That's
doesn't
why.
matter.
Because that's why. Because like additional cut like this, the first one can be voltage, second one can be milliamp. So how am I going to share?
Okay. Okay. But normally, analog is always each of the device has its own COM to go back to the PLC.
Yes.
Okay, got it. Okay, so here is done already.
Yeah. Okay. You add the PLC. Now you go to device configuration. Okay, what is the address of your analog input?
So it's a 0 and 1. So it's a it's only
The first zero.
the first 0
Okay. So what is the address?
for IP for this one.
Not the IP, the address.
The address
So this one is I0.0, I0.1, right? So for analog,
is A. This is I. So this is a 64.
okay, one.
So this is a I64. This I64.
One is IW.
Of W.
Yes. Because it's a value one.
Okay.
It's an integer.
Okay. Always come in A is analog. Always come in is a W.
Any PLC analog is always integer.
Okay, got it. And this come in is a string of this 5-digit string.
Yes.
Okay, got it. So IW64.
So what we do, first we test whether it's working or not. So what we do, I can go to the watch table, add new watch table. Actually, commissioning time you will use a lot of wash cables. No, in the address.
IW64. Okay.
Okay, monitor. So since this is a new project, it asks you to start search, go online.
Okay, found it. Go online. So it's not the same. Right. So I have to note it.
Only the, I just want to see the value of it. So
Okay.
change to decimal. Decimal. Just
Oh,
these.
okay,
Yes,
okay.
Okay. What is the value?
So 2627. But here is
How many volt?
here is a full 10
10 volt lah.
Right.
Okay. So we're supposed to get 27648.
Okay.
Okay. There's some offsets lah.
Okay.
Okay. That one is very common. You just increase, decrease. You can see.
So we use the 0 1 last time. Okay, go to the full 0. So if I go to the next, I go to 5 watt first. Okay, then show 13,000. Go to the full and it show 36,000. Okay, not exactly.
27,648.
Not yet. Okay. 27. Okay. Okay, got it.
Okay.
So this is the value integer we received from AI.
Yes.
Okay.
Now, how I know is 27,648?
This is a fixed number.
Yeah, it's a fixed number, but how I know? Okay. So I show you where I get this data. Minimize.
Okay.
Minimize this. Siemens here. Siemens. Download the program. And then you can minimize this. You connect Wi-Fi. Okay, what you do? I think sometimes you can connect Wi-Fi. Click here. Connect. Okay, what do? You go to TIA, you go offline, you remove your laptop internet. Okay, now you go to Wi-Fi internet. I show you where I get. Click here. Minimize this. Okay. Go to properties. Connect automatically. Connect automatically.
You mean IP or?
No, 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 Wi-Fi.
It's not downloading.
you can copy that.
Oh,
You
okay.
can put in your folder lah.
Oh, I give you my my hard disk. Yeah.
No, no, no.
Okay.
This one I put inside your folder, the channel.
Ah,
So
okay.
later on you can copy them.
Okay.
Later don't forget to copy, yeah.
Okay.
You don't think next week you want to copy because because sometimes I clean the laptop, I will erase everything.
Okay. Okay. This one is the signal generator, this one, and a potential meter is the same thing.
Yes. Using it the same.
They also refer to the same type of
This
output.
is a voltage one. Yeah.
Potential meter actually normally output is what? It's not resistance or I don't know, that's why I asked.
Okay, what's that?
Potential meter. Because I've seen some of the MCC panel, like instead of using VFD to control speed and everything, right? They hardwire, they use a potential meter to control speed.
Control speed. Okay, it's the same thing. Voltage.
It's a voltage also.
It's a voltage.
Oh.
So what happens is normally potential meter will have a 3 wire with a resistance built in. So you connect 24 volt, it will convert into 0 to 10 voltage.
3 wire over it. Okay, yeah, just to know first, but it's the same thing as this one.
IF. Easy. There are a few manuals for TI in the 1200 one. All Siemens one. I give you.
Oh. So the manual for the 1200 is a lot, very big.
Yeah, because one is the programming manual, one is the hardware manual, another manual got PID, how to do PID programming.
Only VFD also have one manual.
Not only PID, a few with the PID from the PID also.
Okay, yeah.
All that I download because I'm doing the manual right for that purpose I download.
Okay, thank you.
Okay. Easy. Okay, make it bigger. Okay, go down. Okay, wait. No, it's the cost content. Under technical specification, the last one. Okay. Go down. Actually, you can click This one is the what? The board.
Okay. Oh,
The board type.
Okay.
Okay. You go down
So,
and lot SBs.
as supporting board or
I'm not sure.
okay.
S. I think S is the S. B means board. That's what I know. M means is a module.
Okay.
So this is the module. So you have 4AI, 8AI, 4AI. Okay, go down. Okay, then it shows like wiring diagram for the AI card, how AU card, how everything is here. This one is the module, the module type. How to do the wiring.
Oh, okay.
Okay, go down. Go down some more. Go down. Okay, this is the battery board. Okay, now specification. You see, CPU, the CPU AI, the SB AI, the SM AI.
Okay, this is the one on
Now we are using
yes.
SB AI is the board. SM is the manual.
This is an add-on.
Yes.
Okay.
So it's a 0 to 10 volt. This one is can be voltage, can be milliamp. This one also same. Can be voltage, can be milliamp. Okay. So the one we are using is, can you see full scale range is 0 to 27648 data volt.
So it's just saying that it's a word type. It's
Yes.
an MW. Okay.
Yes. Okay. Not MW. IW. Because it's an input.
Okay.
So it's showing that the volt overshoot or undershoot means above this. Okay. Then if it is I'm using this one, this is the range lah. Okay, overshoot, undershoot.
Okay, so you say essentially this is not a fixed value like all the IO everything sharing percent. Because CPU is a 0 to 24,000. For the SP actually is a negative to positive.
Because if
27,000.
you're using negative 10 to positive 10.
Okay. Plus minus 10 volt.
Yes.
Okay.
That is a full range.
Full range, okay. And this is a 0 to 10 volt. And
So it's an overshoot, undershoot lah, of course, above the value lah.
hmm.
So that's the same. Okay.
What is mean by overshoot and undershoot?
Means overshoot is if it is value means it's already more than 10 volt already.
Then what will happen here?
Nothing will happen, it's just this value. So what you can do, you can use this data to create an alarm.
Okay, so it can, you mean it can potentially receive more than 27648?
Yes.
If let's say something wrong with the transmitter
Yes.
or device and it really overshoot the voltage.
Mm.
So you receive a value, 28,000 for example.
Yes.
Then I have to do a comparison.
Yes, comparison and alarm.
Okay, got it, yeah.
Okay. Then here's the same lah. You go down. Okay, here. For the voltage and current, see if it is 0 to 10 volt, okay, it's the same number. If a 0 volt is 0, 10 volt means it's 27648. In hexadecimal is 601, 6000.
Okay.
5 volt also same thing. 2.5 also same thing. Okay? It means that it depends on what you select on the module. So the fixed module is 0 to 10. Okay, so that is the range 0 to 27,000. So the additional module, let's say you choose 0 to 5. Your instrument also 0 to 5. Okay, so means that if 5 volt means 27,000.
And you say choose this on the configuration.
On the configuration you need to choose. Remember yesterday we changed the voltage milliamp. So in there you must choose. In the configuration, you go to the card module property, you can change.
I know what you say. I'm just curious, because think about this, very rare. At least I never seen plus minus 5 volt or plus minus 2.5 volt.
But for this project, I'm using the 2.5 volt.
Oh, plus minus 2. I mean, there is a.
20 to 2.5 volt because the sensor is here.
Oh, they are really in this some sensor is using.
Yes, yes. This
That's the reason that they give you to choose.
But this is not for industry lah. That's the thing. This one for small scale. This is a CO2 sensor.
And their output is plus minus 2.5.
Just 2.5, 0 to 2.5.
0 to 2.5.
Yes.
Oh, that's the reason.
So
You
I
use this
need
for
to,
higher resolution.
yes.
Okay.
This one. It's just using 0 to 2.5.
Got it. So it's really any type of
Yes.
sensor.
But common industry is 0 to 10 lah. 0 to 10 or 4 to 20 only.
Right.
Yes.
Okay. Got it. So there's a option for you to choose and you
Yes.
want to do the configuration.
Yes. So we need to know. We need to know what is my device and also what is my, in the PLC I need to choose according to my instrument.
Got it. Okay.
If no, okay, it's like this this is PLC, this is your instrument, okay?
Okay.
Let's say the instrument is 0 to 5 volt,
Right.
but you choose 0 to 10 volt.
Okay.
So what happened, in the PLC you will get 0 to half how much?
30,000. Yeah.
Not showing here, okay. So
Oh.
13,824.
Okay.
So you will get this number only.
Right.
So if you want to do scaling, you must use this scaling. If you do scaling with this one, then you will get a wrong number.
Right.
So that's why you must choose. But since the building don't have 10 volt, sorry, don't have 5 volt, right? It's 10 volt only. So I use 5 volt, never mind, but I need to know this is the value.
I got that one. Okay.
Yes.
So I have to be careful of the scaling and the configuration.
Yes. So both must be same. If not same, so you need to know how to do the calculation.
Okay.
The calculation is very simple. You get the analog input value 0 to 27,000. Example, you convert to what? Let's say it's pressure.
Okay. Pressure.
0 to
0 to 8 bar, for example.
0 to 8 bar.
Okay.
0 to 8.
Okay.
If let's say it's a 0.5, I mean 0 to 5 volt, but you choose this one, then in the calculation you must use the 13,000. Then only you will get correct value. Or make it 16. The value.
This part is scaling function.
Yes, this is where you do the calculation.
Okay. Okay.
Okay, good.
Okay. Good. Yeah.
Okay, so this is where all the data you can take. Okay, go down. Anything else I want to show you? This is the current. Current also same. 0 milliamp, 0, 20 milliamp, 276 point.
Okay.
Okay, same thing here. You see, 4 milliamp also 0, huh?
Yes.
Okay.
Yes.
So it's depend on you which one you choose here.
Okay, fine.
If you want to do like this, okay, when it's the cable break, I want some alarm. So what you do? You choose 0 to 20 milliamp. Okay? But here you use the 4 to 20 milliamp. Okay?
Okay.
Then what happen is below, so it become means you choose 0 to 20, but your instrument is 4 to 20.
Okay, so there is an option to choose 0 to 20 as well.
Yes.
Okay.
So you choose 0 to 20,
But actually my instrument is 4 to 20.
4 to 20. So
So
what
scale
happened?
from here.
What happened is your this one your value start with from here,
Right.
somewhere, something like this, right?
Yes.
Yes. So
Okay.
you must calculate like 4 is what? I think 4 is around 5,000 something.
Right.
So if value you get below 5,000 or the analog value becomes 0, so you know the cable is break.
Yes. This wire break function is built in. I mean,
Built it, I'm not sure.
yeah, just asking, right? Because it's a very common industry. Just like I
Yes,
said,
yes.
all the time they're using this function. Okay, so this is the scanning
Mhm.
and configuration.
Yes.
Find the value is normally it's always 0 to 27.
27, 6 for 8.
27 to 32 is overshoot
Overshoot
and below 0
is underflow, undershoot or
undershoot. Okay, got it.
Go
Yeah.
down. There's a frequency also to select. 400 to 10 hertz means how frequent you
Scanning time.
yes,
Yes, sir.
there's the scanning time.
Oh, okay.
So how frequent is it? So to avoid the fluctuation, if the scanning time is low, means very fast scan, the value will fluctuate very high.
Question.
Yes.
This scanning time and the PLC internal calculation scanning
Because
time.
we can choose in our PLC.
This is not for the I/O scanning like
Yeah.
separate. It's a SEM.
Same.
SEM. So I
No,
mean,
no, no, okay. You mean the I/O scanning?
I mean, is this scanning is the same as what we said? Because like I say, like we said PLC, right? Let's say this is a 1200. I don't know what the scanning time. I assume okay 20 milliseconds. So every 20 milliseconds, the whole function log, all the OB
That is
calculation.
that is the cycle time.
Oh, that's the cycle time. Okay, not the
Yes.
scanning time.
That
Okay,
is
it's
cycle
different.
time. That is what you mean is for the programming.
For the
and-
programming,
Yes.
yes.
This scanning time is only particularly for this input only.
For this input of it.
Yes.
Okay, how many? You can choose a very low
Lowest,
scanning.
lowest is the 10.5.
Oh, okay. Or
The
lowest
higher the
one.
hertz, the lower the version.
Yeah. Okay. So I can choose whether I want a very frequent scanning or very slow scanning.
Yes.
Got it. Okay.
Okay, go down.
Got it. Okay.
Yeah, that's all.
This is part, and all here is part of the configuration.
This one part in the configuration you can select.
Okay. Okay.
But not for the building. Not for the building analog.
Built-in, you cannot select.
Yes, only for the board and the module.
Got it. Yeah. Okay.
Okay. Minimize. Okay, go back to TIA. Okay, so we know we get some value lah.
Yes.
Now go back to the end, main OB. Okay, never mind, we can do it in the main. So you know instruments, right? Okay.
Yeah.
Analog very simple. Anything is you give a range is considered analog. Make sure it is the analog value, because sometimes the people thought range means analog. No, analog means just only the two range. One is the voltage 0 to 10 volt or negative 10 maximum lah, minimum negative until positive 10 volt or 0 to 20 milliamp.
Okay.
Only these two is the analog values.
Okay.
If other than this, let's say 0 to 24 volt, it's not analog.
Okay.
It's not considered analog because PLC cannot read that values. 0 to 24.
Okay.
Cannot
Okay.
read. Okay. So input is very simple. Anything you can measure, and that particular instrument can give you these values is analog.
Okay.
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 Output also same. Analog output mostly you control what?
Valve, anything like.
Valve, pump, VFD. Okay.
Yeah.
If you see carefully, anything that is rotation,
Okay.
anything can rotate, or anything that is motorized.
Okay.
Other than that, what PLC can control? What is the analog output?
actually
If
still
you
a lot. Heater, for example.
Heater.
Right. You give a
Heater?
heater to control the voltage of the heater. But I don't know. But definitely there is an in between. There's a
But it's not a-
transducer lah. Yeah.
Yeah, of course transducer.
Yeah.
But normally heater is a coil. Coil.
I'm not exactly sure how to convert from the PLC until you can control a heating coil. Yeah.
Heating coil, okay. That one, that's what we're going to learn in PID.
Okay. Yeah.
Because PID is a heating coil thing. But I just correct you. Heating coil is just a coil.
Right.
Means just positive, negative. It's considered a digital.
Okay.
Like our kettle. It's considered a digital. You turn on, it just keep on. Then
There is a voltage control, right?
yes, of course, there's a voltage to control. How the voltage we control? Will up 1 0 1 0 1 0 1 0.
Okay, I'm not familiar. So you say that heating coil is not giving you like this heating coil that let's say it's something like a VFD lah. If you control your voltage to how much to give you different temperature. Is it on off on off on off? How very frequent on then is a more heat.
Yes.
If on a little bit then off very long, then that is a cool down.
Yes.
Okay. Okay. So that is either is a okay. I don't know. Don't want to assume because I don't know how the heating coil control works.
Yes, that's what we call pulse width modulation.
House with modulation. That is how to control a heating coil.
Yes. That's what I said, like on off on off on off.
Okay. Okay. Got it.
So normally that's why because when you say I also can when I see you say can be used to control heating coil often is called pulse width modulation.
House with
Or you
modulation.
can use the solid state relay.
Okay. Okay.
So still the concept is on off on off.
On off.
Yes.
So this is okay. Okay. So this is
So when to on, when to off, you need to do programming. Like a heating coil also was. So when to on, when to off, that's why the pulse modulation. So if you okay, let's say the heat temperature is low. Now you want to reach 80 degree. So what happens? The pulse will be on, off, on, off. Once you're going to reach, it become like on, off, to
I
maintain.
know what you're saying. But I assume in an industrial environment, maybe people will not directly use a PLC to directly control the element itself. This is to direct control the coil itself.
No, they
Because
must use the
A controller in between, right?
in the controller in between lah, of course can also, or just a solid state relay also can.
Right.
Or of course normally they use solid state relay because why? Your PLC is DC, but the heating coil won't be DC, it must be AC.
Right.
So must use a relay like that.
Right.
Also can. Or
Okay.
some controller which is controlling the heating coil. So your PLC, the controller itself, you can give analog.
Yes.
But if you see carefully inside the controller will control the coil
It's
in
using the
pulse.
pulse.
Yes.
But the most important thing is PLC give command to the controller.
Yes.
It's a 4 to 20.
Yeah, for 20, 0 to 10 also can.
Yes. Yeah. Okay.
Okay. So very simple like because that is considered that controller also is function like a PLC also.
Right. It's a controller. It's actually just like a VFD. It's also
VFD
a
lah.
controller.
You get the
Yeah.
analog input.
Yeah.
You control the speed according to that.
Right.
You will arrange you will control the voltage.
Right. Control the
Yes.
voltage. Yeah.
Okay, now, so let's say, so the analog now is 0 to 27, 6, 4, 8, okay? Then you want to convert to 0 to, let's say 100 degree lah, okay?
consider.
No, yeah, wrong.
Okay.
It's supposed to go the next step. I will go to the point of this. Okay. So what formula we can use? Y equal to mx plus c.
Okay.
Common one. Jadi got so many formulas. So this you can use the just now we do the calculation same method. Okay, to get the m. Okay, y maximum minus y minimum, x maximum minus x minimum. So you get the m. X is your analog input. C is your offset. Y minimum minus m multiply x minimum. So if you want an accurate value, this is the calculation you need to do. Get the m, get the c. So you will get the m, x is your analog input, c is the offset, y is your temperature. So you do a calculation like this, you can get a accurate value. Okay?
Right, that is a, okay.
Yes, sir.
That's a formula.
That's a formula lah. Okay? So if you don't want to use this type of calculation, you want long calculation also can. Just replace the m with this one and replace the c with this one. Become long calculation.
Right.
Okay? But all the PLC, whatever, they have their
Scaling function.
scaling block.
Okay.
Okay. So it's under the conversion operation. Yes. Norm X. Yeah. Scale X.
Oh, both we use.
Both. Okay. So can close. Can close this one. Okay. Norm X scale is this one is the for the X axis. This one for the Y axis, right? So this one will normalize the value. Normalize the value means it will convert this value into a percentage. But it's not 0 to 100, it's 0 to 1%. Okay? Then multiply with this one, you get the value. Okay? So we do 1. So here is the input. So your input is analog input, right? Correct. IW64 is an integer. Okay, choose integer. Then this one must be in that real. So there's no other option.
Okay. And this is
Here.
Okay. Real to real.
Real to real. Okay, very good. And this one is depend on the program. What is the temperature you want to read, in real or in integer?
Okay. Yeah, probably he would really want the integer, like 27 degrees, something like this.
Yes.
Okay.
You want 27.5, then real.
Okay.
Okay, good.
Subject to what he want. Okay.
Will depend on the programmer
He
lah.
option to choose lah.
Yes.
Okay.
This one must be follow your analog input.
Okay.
This one no option, real. This one also, this one follow this. The last one is depend on the
Programmer.
programmer. Okay.
Okay.
Now minimum maximum this value. Minimum maximum.
This is get from the manual.
Yes.
And this is the fixed value to key by the programmer.
Yes.
I try to think why this value here is not part of the configuration.
Part of the configuration means what?
Think about this if the Siemens, he's a supplier, right? He give the option, he say that 0 to 10 watt is a 0 to 27,000. And then he asked the people to do the scaling.
Or ask people to do
Zero-
scaling.
Yeah, and do the 0 to 27,000, like key in 0 to 27.
Oh, okay, I understand.
He should be in the configuration, he
I
said it immediately.
totally understand what you mean. Okay.
Because this one, big people do mistake. Yeah.
Okay. You are correct. Okay.
The reason I say is because I've seen time to time. It's not to say that people make mistake. It's like,
Okay, there is an advantage and also disadvantage.
okay,
Okay, I will tell you what. Okay. I know what you mean. Okay, we go back to the SIMATIC manager.
okay,
Inside SIMATIC manager, they call FC scale, FC105 scale, means it's in the library. It's not, they don't have this scale, unscale, or I mean Normax scale don't have.
Okay.
They have a library for FC, but this actually like, or you go to instruction, this Normax scale X, and go to some communication.
Communication.
Yeah, is OPC communication or anything. No, not like this. Others.
Okay. Others.
Modbus? Okay, Modbus, for example.
Okay.
For example, like this, right? So they already have this block, okay? In SIMATIC Manager, they have something like this, but they call library. Under the library, they choose some the programmer, or I mean the Siemens already create for you. Take some FC number. Okay, this one is for scaling. This one is for Modbus communication. This one for PID communication. So they have in the SIMATIC Manager. Okay?
In the old SIMATIC
In the old SIMATIC Manager. So it says SIMATIC Manager FC105 is the scale. It is for AI scaling. Okay. So what happened here is the input, minimum, maximum, and this one got bipolar, default bipolar. I will tell you what is that. This one is the return value, and this is the value or output, I forget. Now what is this one? So here you just put AI. And this minimum maximum what you want to scale. So 0 to 100. Okay, the bipolar is to choose whether the value from like this value or like this. Okay, so this one you must create a memory that is always off. I mean false, always false. But you can leave it empty because why? It's the FC.
Okay.
Then return value will be in MW 10. Okay, because it will be in word. That is, here will have some coding. What coding is? If the value is out of the range, you will get some number here. Some number. So you can use that number to create alarms.
Okay.
Then the output must be MD because it's a real any number. This is where you get the temperature.
Okay.
Clear?
Yes.
Okay. So anywhere you key in this value? No.
No.
Why? Because this number, like you said, is already inside here.
Right.
Okay? Already inside here. So no need to just key in the AI already. Enough.
Yes.
Okay. Now, when I do SIMATIC Manager, for me it's very easy. Okay, easy to understand and to read. But if I want to do some other calculation, another linear scaling, but not this number, it's a different number. I need to do manually calculate using this formula. I cannot use this one. Why? Because this one is already fixed in this number. When you come to TI portal, they remove this one, they make it like this. So you can do any type of calculation. Means any number you want to convert, you can convert. This one is only 0 to 27,000 only I can convert.
I understand what you say.
Okay.
But logically, let's say I give example. Let's say
I know what you mean.
if we know the device is what already, then we know that we have to configure it to 0 to 10 or 4 to 20 or 0 to 5. If we know that, we have to configure to that.
Why not day one? You just
Then you just choose by yourself and don't let the people make mistake.
Yeah, but what happened is only analog can use this. If other than analog value, any other number you want to convert, because
like from Modbus something.
no,
like that.
only Modbus. Okay, let's say very simple. This drive also, they have some value. When the motor running, I get the feedback.
Right.
It's a value. The value is 0 to 16,000.
VFD give an AI is
0 to 16,000.
0 to 16,000.
I want to convert into RPM or Hertz, right? So in that case, that the drive AI, I cannot put here to do the scaling.
When you say 16,000, of course we have to go to there, but VFD give signal back to PLC is a choice of can give a 4 to 20, right?
If you use analog, it's 4 to 20, still 0 to 27,000.
If you use a Modbus,
If you use not Modbus, if you use Profinet or Profibus,
okay.
0 to 4,000 in hexadecimal. In decimal is 0 to 16,000.
Because we haven't touched that, I don't know lah.
No,
I don't know how
it's
to
the
the
same.
Modbus how to breed it, yeah.
No, not Modbus. Only to go Modbus.
Yeah.
Okay. If you're using AI, AO to control the speed, same thing. Like
Right, exactly the same thing.
the same thing. Okay.
Then actually it should not
Should
not
use
use
this one.
this one. Yes,
Yes,
should
okay.
use this one.
But if you're using communication,
Which is not a
it's
AIO.
not AI, AO.
Then
It is communication, so the value is 0 to 16,000.
right.
So if I'm 0 to 16,000, I cannot use this already,
Then you have to use a custom scaling.
my own calculation.
Right. Right.
So in this case, here, since the value is 0, I can use this to scale my VFD also can, analog also can.
So I think you say that in the past.
It's
don't
only for
have-
analog.
Yeah, they don't have custom scale
For
feature
other numbers.
For other numbers.
Yes.
But they assume everything is AIO.
Yes.
But nowadays a lot of this you have to do a custom scaling
Yes.
because of this non-AIO
Yes,
communication.
non-AIO communication. So Modbus, because when you use Modbus, different drive, that drive will be different value.
Everyone is different.
Yes.
So if they standardize it, everything, just you key in the value
Yes.
yourself.
That's number one.
Okay.
Number two. Now the value is not 27648, correct? You want to get 27611. Correct. 0 to 10 volt just now, you get 27611.
Okay.
Correct.
Okay.
It's not. So it's like what some offset.
Okay.
So if it is offset, what I do, let's say that this value go here. Here I won't get 100, exactly 100. Correct. I will get 99.8 something.
Right.
So what I do, this one I need to calculate manually what is the offset, everything. Later on I need to plus some value, then make it 100. Correct. And this is the, so I take this value, do some calculation, do some math lah, just plus, then only I show in the HMI. Okay?
If I'm very keen to show the 100
Yes, of course. Because sometimes there's some offshot, show some offshot,
Right.
some offsets. Okay. In this case, I just change the 0 to 27611. So I don't need to do the calculation.
Okay.
Okay.
I go what you say.
Then why I say this one is better? Here is also better. Okay. But I prefer this. Why? All the PLC this method.
All the PLC also
Yes.
manual key in
This
the
method.
scale.
You know why? Only Siemens that have this. Why? Because only Siemens, the 27,000 is fixed. Means the S7-1500, 400, ET200, 1002, 1005. The 27,000 is fixed. Okay? So that's why in the back in days, the SIMATIC manager used this method.
I know what you say.
But other PLCs not fixed. Like Allen you can get 4 type of values from one analog.
4 type of value from one.
4 different values. One is in percentage, one is the engineering unit, one is the raw value. like Omron, like this Omron, right? You see here there are two type of Omron. This small Omron is 0 to 4,000 only, the range. The bigger Omron is 0 to 16,000. So they cannot fix like this, correct? They must use something like this where the minimum maximum the programmer need to do.
And
I know you're concerned about the guy who doing the programming, alright?
it's not only this, it's also concerned on, you see programming guy, a lot of the time I see, it's not the person on site.
Yeah, of course.
And then they think there's a lot of gap, there's a lot of communication gap here. From the start of he do the programming, he received an engineering specification, right?
Yes, yes.
I have a list of 100 instrument here, and then this is a 4 to 10T, this is what, and then based on this information, I do the configuration. I key in on IO1, AI1 is a 4 to 20, AO2 is a 0 to 5, whatever. Because of this, I key in the min-max like this, and then go to the site. Probably definitely the guy, do the VFD, probably he do not know what the heck, he don't care about what is your
Yes.
PLC doing.
Yes.
He just configure, finish, bye-bye.
Yes.
And then the commissioning guy, also probably he do not know what the automation guy think about it. Then he find out, this is wrong, and this cannot communicate, or this one keep on giving a wrong value. It's about the configuration here. Just like you say,
Like if you have a standard configuration, you won't have a confused lah. Correct?
if
That's
there
what
is
it
only
is.
one person do everything, then there is no problem.
Of course, of course.
But the problem is there is so many
If
people
let's
taking
know,
a small part
if
here.
it is
There's a lot of mistake. The mistake.
can
Can
happen.
happen,
Yes,
yeah.
I know what you mean. If they standardize the configuration here, so if multiple guys
Yeah.
do so, the configuration is
Yeah,
there.
you wouldn't have problem.
Yes.
But there are so many places it can cause a mistake. Yeah.
Yeah, of course.
I just try to think no, it's not to say I'm good or not good. I just understand only. Okay, so the scaling is
But
scaling block. You have to key in a manual value here.
manual like this, okay?
Yeah.
But you can make this into this also, okay?
Okay, there is option but
That is, you can find one function, take one function block or one function FC. Inside the FC, you create this, you fix this value. This one make it like an input variable, the output make it as an output variable. The other tools, then it become like this.
But it's not solve the problem. Is
Yeah, it's still not solving
Yeah, you're not solving.
what you
it's
require.
a mistake. Yeah,
Yes.
you still have to somebody have to manually go inside and
Okay,
check.
why they didn't do
Yeah.
this if you ask me? Because what it mean is that the same thing they have in Schneider, you can do the configuration. LMW you can do the configuration. So means you don't need to go to the program to know what is the value. You can see in the configuration, you know what is the value already. Okay?
Yeah.
Okay. But if you ask me why Siemens don't have, because Siemens have a standard number. It's 27,000 it's a standard number. That's why for Siemens, if you ask me, it's not necessarily.
Okay.
If you see other peer, because since I didn't buy others, if I see others, they have that. What do you mean?
Like
you can
configure
select.
immediately. They give you
You
what you want.
can select whether you want to use 0 to 10,000 or 0 to 20,000, or some PLC you can manually key in 0 to 20. What number you want? You straight away can key in 0 to 100 degree. So you don't need to do scaling also.
Okay, direct from the configuration.
Right from the configuration, you can directly can key in also.
Even easier. Yeah.
Yes, even easier. Okay, but when I think deeply, why they have that option, this one don't have the option? Because they don't have the fixed number. Different. Same Siemens, same Mitsubishi. One is the bigger module, one is smaller module. Smaller module different value, bigger module different value. Like Allen values you say. Different module, different values. Only Siemens, you ask me, only Siemens is all the module is the same number. So that's why for them it's not necessary. Maybe I'm not sure.
But because pro side is very customizable. You want how to calculate also can. But the con side is there's
Yeah, what do you mean?
Yeah.
When you for you, if you ask me, for you it's difficult. For you it's like troublesome.
troublesome. Yeah,
For me-
instrument, they buy a wrong transmitter, or they already find mistake. You change change on the field is difficult already. Wiring difficult already. You come here, you change the configuration. That person forget again, has to come here to change the scale again and so on.
Mm.
It's a lot of things have to change. Yeah. But it's a small thing, it's a small thing. But I
No, I know what you mean,
step
because
here.
this is the part you normally you can involve everything, right?
Yeah.
But if you ask me, for me, this one is easier because like for me I'm a programmer.
Right.
For programmer
programmer
it's easy. Right. For
Right.
those who do the commissioning part, they will find it difficult. Okay, but for you, okay, you can do like this. The thing is, let's say for example they already do the commissioning, okay, and you find out the instrument is not. You need to change the instrument. For example, okay, let's say like you buy a wrong instrument. It's supposed to be 0 to 10 bar.
Right, for example.
Yes,
yeah.
but you bought 0 to 6 bar, for example. Okay, so which is not enough. Okay, so what you need to do is, first thing is, okay, you check the hardware configuration, whether it's a 4 to 20 milliamp or 0 to 10 volt.
Right.
Okay, you need to see. Okay, I will do here maybe. I can get some idea. So you also can get some idea. Okay, this is the PLC. This is the instrument. Initially, it's a 4 to 20 milliamp. Okay, and okay. Now, the new instrument you buy is don't have the 420 milliamp. It says 0 to 10 volt.
Okay. Yeah.
So in that case, so in the configuration you need to change. Okay. Can I erase this?
Yeah. Sure.
Okay. I give you idea. Maybe you can, but still like it's similar like what you said lah. Of course you need to do the settings. You cannot get away with that. Okay. X skill X. Okay. This is the AI. This is 0. Then this is the empty cap. Here I put empty. I just put empty example. Then this is the pressure. Okay. Let's say earlier is 4 to 20 milliamp. So 4 to 20 milliamp. Okay. So how the programmer do? 0 to 27, 6, 4, 8. 0 to 6 bar.
Right.
Okay. Now you do this already. So AI 3 for example so AI. Now you check and see the 6 bar is not enough. You need to go by 10 bar. Okay.
Right.
You buy 10 bar, then it is 0 to 10 volt, right? So what you have to do, you check this, change this to 0 to 10 volt, and you go to the AI 3 and see where they can do the scaling everything. Okay? Then change this to 0 to 10. Okay?
I know what you're saying.
I know.
In the ideal case, this is what happened. Yeah,
Yes,
in the ideal
okay.
case, this is what happened. Yeah.
Okay. This is a very straightforward.
Right.
I give you like a big time. That is, let's say here they choose 0 to 20, but earlier it was 4 to 20 milliamp. The hardware side, let's say, is only available 0 to 20, but the instrument they use is 4 to 20. So when you do conversion, they will put like here is the 5,500, for example. Let's say 4 million is 5,500. This is how they do the program. Initially it was 0 to 6 mark. So when you convert to 0 to 10, again, so this time you only not change this one to 10. You need to change this one to 0.
I know what you're saying.
Yes.
In the ideal, you have 1000 IO for analog. If you only have one mistake,
Then it's
very
okay.
easy.
Yeah.
If you have a lot of people miscommunication,
Mm.
you find out the trouble, and then the program cannot just simply, because I do commissioning, I simply change or whatever. I have to verify a lot of things. Whose mistake is this? Who have to pay the money? All this.
So
Then it will be very
you must go
complicated.
back to the go back to the programmer lah.
Yeah, a lot of and how do you say that? I mean, it's not a programming issue, it's not a programming issue, but it can be as simple as, the programming guy think that, this one I need to be 0 to 5 watt.
Yes,
I need to be 0 to 5 watt. And then actual side come out as a 0 to 10 watt thing.
Yes,
Yeah,
yes.
It could be something like this, as simple as this. and then-
Can happen.
Yeah. And then the people do check all the time, they've got problem or whatever. And then-
Sometimes they do mistake in the configuration also.
Right, mistake in the configuration also.
Yes. Because why? 0 to 10 volt or 0 to 20, 0 to 5 volt, this value is the same. So programming we won't issue. Not have an issue, correct or not? But when you do the configuration, sometimes the first one is 0 to 10, okay. Even I myself, when I do this program, because this PLC, the AI card called AI, is mixed, The first channel is only voltage. Second channel only can choose to milliamp.
Okay.
Third channel voltage only. So what I did, first time I confused. I confused really, which one is now voltage, which one is, because before I do the configuration, what I did is, I do the tagging first.
Okay.
Then when I want to do the configuration, it's not same. Because my tag is voltage, supposed to be voltage, but here is milliamp. So I redo again. But it's still only 11 AI only lah. That one also I know what you mean, because I put one by one, I take note, each one I finish, I tick. Make sure I don't do mistake. So when it's involved hundreds of analog sound, of course.
This is how it works. This is how it works. Yeah.
Yes.
This is how it works. Okay.
Okay.
Got it.
You
So
minimize this.
have the manual key in.
Yes.
This
IW64.
is IW64, and this is the 0 point something.
MD something.
MD something. Yeah.
Yes.
MD something. The value will be 0 point something, and
Yes.
automatically it will transfer this one to the scale.
Yes.
Min-max is my range I want. 0
Yes.
to 5 bar, 0 to 10 bar. Out is the bar value, the pressure value
Yes.
in the ring.
Yes.
And then I use this for PID or
PID.
calculation.
Actually, PID you don't need to use this.
Okay.
Actually, you have option to use this or straight away the analog also.
Straight away analog also can. Okay.
In PID, no problem.
Okay.
Okay, now you key in this value, you just see what happened. You just close this one.
Okay.
Yes, this IW64 display unit.
Okay, IW64. This is MD. I just use a new MD, right? So it's MD 0.0. MW.
MD, real. MD?
Oh, 0.
0, yes.
Okay. In is 1, 2, 3, 4. And this is so say that this, I want to use 60. here is I will receive a value MD4 is the
Temperature.
temperature or whatever depending
Oh,
on
you put 16.
yeah.
So it's a bar or something lah.
Right. So if I run this and I turn this and this
Can get yes, download. Okay, stop module. Stop the module because new project.
okay, yeah, now okay already. So run it. So go to 5. Eight here. Okay, yeah.
Yes.
Yeah, so it's a working, yeah.
So if you want to do in function block, so
Okay.
I show you one. Okay, go offline.
Okay.
So once you get this one, then you can use the compare to on something. Let's say we do here. At the same time, you can learn compare. So click here, instruction, you take a comparator. Okay, just choose one compare less than or more than.
Okay.
Hmm.
So okay, just choose less than here.
Okay, in the middle, actually no need to select lah. When you select MD4, you put MD4, automatically the data type will follow this. Clear?
Okay.
Okay, then below you need to do from what number you want to what? Compare.
So here is a 0 to 16. I say that lower than 8,
Yes, then you want something.
then I want something.
Yes.
Okay, I just make it more. Okay, 8. Just key 8 on it.
Yes.
Okay. If this is lower than 8, if you
Just turn on one lamp line.
okay. I just try to think if I do I make a reset button, how should it work? Should this the normal this one, right? I just like imagine I0.
Okay, you try.
Okay. I assume this is a reset button,
Mm.
and then it will reset the queue.
Mm.
Oh, okay. So everything is running. Now the value is lower than 7. So it's okay. It's lower already. It's triggered. It's not resetting. For example, my real value is 6.7, right? I say lower than 8 and only send out a signal. And then now it's not, it's lower than 8. Oh, okay, it has to be higher.
Yes.
Okay.
Then you press the button, then only it is set.
Okay. So this is either used to command or used to alarm is definitely using comparison.
Yeah, of course. After digital, very simple. You see, digital buttons, right? You just straight away use as a normally open.
Okay.
If analog, you do scaling, then you compare. Actually, this one is similar to your normally open also.
Got your point.
That's why the symbol also same as this. It's considered normally open, but with a condition.
Okay. It's a normal open with a condition.
Condition.
Okay.
Because it's a value. Actually, you don't need to do scaling also.
Okay.
You put to 8. 8 volt is what? Half, right? Correct. Must be half.
Okay, yeah. For example,
Okay.
8 volt is
8 volts is half lah, right?
right.
So you put here 16. Okay. 8 means 8. So 13, 8 to 4. Okay. So now you comparing what? MD4, right?
Right. And
Compare
before.
with 8.0.
Okay.
Set. Outline. Okay. If you don't want to do this, you can still do this. Straight away use the IW64. Instead of use 8, you can use 13, 8 to 4. Still the same thing, right?
I got your point. Okay, then, I got your point, yes.
Still the same thing, right?
Yes, still the
But
same.
why they don't want to use this? They want to use this because number one, maybe they want to show this the value of the scaling in the HMI.
Right.
If you don't want to show in the HMI, so it's up to you. You can use this or use this. If you ask me, I use this. Why? Because when I do programming, for me also is easy because I know why they put it. If let's say I don't know how to do scaling, for example, I can use this. But 8 means what is the value I need to calculate manually.
Right.
In the future, if someone go and do some modification, they want 8.5.
Right.
If it is 8.0, easy to change to 8.5.
Right.
If it is 13, 8 to 4, not easy. Need to calculate again.
And probably another reason also is this alarm, the programmer doesn't know what is the correct set point have to set.
Yes.
He has to give the option to the end user to set it from
To set the value.
HMI.
Yeah. What I mean is, if it is, of course, if it is involved HMI, you must do this.
Okay.
If not involved HMI, you have two options.
Either you want to set in the real.
You want to use
the
you straight want to compare the value, the raw value, or you want to compare with the converted value.
Okay. Got your point.
Okay?
Okay.
Okay. Now we go offline. We do one function block. Let's show you. Okay. You go to add new block.
Okay.
Function block or FC. Okay, now function block. FC also can. Okay, you put AI scale. Okay, I still use ladder. Okay. Okay, you open this. Okay, you put here AI. Just put AI. AI data type is integer.
Okay. Integer.
INT. Okay. Then the output you just put scale value.
Okay, so
So
we
or
are
scale
creating
value
a,
or scale output.
okay, we're creating a custom scale.
Custom scale, yes.
Okay.
But we're still using the norm as scale X only. Not AO.
Oh,
Cannot put AO.
oh, not at all. It's a output
It's a
scale
scale,
value.
the scale value, yes.
Scale value.
Yeah. Okay, here, okay. Then the temporary you put norm X.
Okay, no next.
Okay. Then the constant
Real.
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 Constant, okay, for constant I don't need first one.
Okay.
Okay. Close.
Yeah, essentially we also can create our own
The
tensor
SC.
scale.
Yes.
Okay, okay.
Okay. Here you put. No, no, here. No, no, okay, you go up, some more. I need to add some more. Okay. Scale minimum, scale maximum.
Okay.
Because the output minimum, maximum we need first.
Okay.
Hmm.
Scale.
Min, scale max. Yeah, this one follow the scale. Okay. Now can close.
Okay. So already.
Now close. Okay. You just take the norm x, scale x under the conversion. Norm x, scale x. Norm x.
So this is
Here the scale x. Okay. Then integer, real, real, real. Now here is fixed value. Just put 0 to 27648. This one is AI
276.
648. Okay, this one AI. The AI just now we created.
Yeah.
The name AI, right? Yeah.
Yes.
Okay. Then this one is the norm X. Okay. This one is the scale min, scale minimum. Okay. This one is the norm X. Okay. Then scale maximum. Okay. Then this one is the scaled value. Okay, so you do something like this. Then you can create your own alarm everything. You know?
I know. Question.
Yes.
Normally, I mean a good practice, how is it supposed to do this? Especially for AIO, because DIO, you directly use
Yeah,
the
direct.
ones, you know. AIO,
You
always,
do like this is better.
Yeah, I mean, how to arrange? For example, I say this project probably is only one PLC, and then the AIO is limited, right?
Mm.
Probably there could be like 4 or 5 only. Say some project you using that one, you have a multiple, quite a lot of IO card. How to arrange this scaling? Normally, it could be like, I mean, maybe it's like everyone has a different preference, or maybe people find it easier to work with all the AIO in one subroutine page, or everything just crowded in the
No, one subroutine.
one subroutine, easier to
Maybe
manage,
AI one subroutine, AO one subroutine.
and also follow the card also. Card one is a one subroutine page.
No, no, no,
No need.
no.
Okay.
Or that one is not necessarily like
Not necessary.
Yes. We can
Maybe
just
it's
do
one subroutine. This OAO is here.
Yes.
OAI is here.
Yes.
Okay, okay. Okay, so
Okay.
yeah.
Then if you want to do some additional functions, means can lah. Okay. Means like overshoot, all that. Okay.
This is a function block. Okay, so first in the function block, it receives a signal, which is an AI,
Yeah.
and then you give a scale value. Scale max is from our function block. This kind of variable is input also. In this input from outside also. Norm x is temporarily inside, so it's not shown outside. And then we can create this one directly with an alarm. Alarm is a comparison.
It's depend lah if you want to overshoot or want to overshoot alarm or that.
Okay,
Ah,
this is from the instruction. Okay.
yes, yes.
This is instruction. Operation. Comparison is in the comparator. So we assume that this is the same thing as like if it's out of range. Oh, okay. More than okay. If
For this project, I did like this.
okay.
For this project, I create one FB like this. Then I create another FC. All the FC I call them.
Okay, okay. So one F, your FB is a template for
All the
all
blocks.
the type of the
Yes, I don't need to do normal. Okay, I can do that
Right,
also.
repeat.
Ah,
And then you have a
one
Yes.
subroutine, yes.
and then we include all the your AI in
Arrange
one.
all this, I do that.
Okay, okay. So this is scale value and compare with something just
Scale value, compare with. You want to do what? Overshoot or what?
yeah, anything. But since
No, okay. You put the AI here.
okay,
You put the AI here. It's a choose in real, say integer. INT. Okay, the scale value take up.
so it has to be something integer here.
So to overshoot, let's say 27649.
Okay.
But of course, like it won't go up to there, right? So what you do, you put 27600. Because then you create one more output. You go here. Actually, you can create here itself. Okay, never mind. You put one output. AI overshoot. Okay. Right click. Define tag. Okay, define tag as a don't go for global memory. Global memory you put local out. Okay, define. It's a boolean, no address. It's a boolean, yeah. Define means why cannot be clicking? Is that okay? You close. You double click again. Delete. Okay.
Delete. Okay.
No. Because must have the hashtag in front. Okay. That's why. Alright. So something like this. For example,
Okay.
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 Finish. Now you go to main main we can call lah, no problem. Okay, no need to pay the FC.
Okay.
Okay, go down. Okay, now you take this, put it here. Put it here.
This is a function block.
Yes. So you put here temperature. Okay. Now, what's your AI? IW64. Use the same channel.
Yeah. So
Okay.
this map to my
IW64. Okay. So let's say the output is 0 to 100. So 0 you can leave it 0, 100 only you can leave it.
scale 0 to 100.
Okay. Then the scale value, of course, you need memory to store.
Okay.
So you put MD what number just now? Until 4. Okay, MD8. Okay, then this one is Q0.1.
Q 0.1.
Yes.
Q 0.1. So the score to 0.1.
Okay. So what you need is on top you go up. Actually, network 1 and network 3 exactly same thing.
Right.
But network 1 you have like Nomax, KX, both
Right.
PTE and everything.
Right.
So what you do, this one you make it into one function block. Go down on function block. Then you from this function block you can get a lot of data.
Right. Right. Question. So now because we are using one CPU, right? It's about the configuration. Says now if this one just start with has attached to another analog card. Yeah, analog card. It is during the configuration, as long as all the analog card are reporting to this PLC, so the address cannot be config, right?
Yeah, can of course it will be different addresses.
So that is where in the configuration is we define this one is
64, 66,
64, yeah.
and so on that 68.
Yeah.
If it is different number, you in the configuration you can change one.
Right.
You can change. You can arrange properly the numbers.
In that case, this PLC when we do the programming here, we don't have to worry about this is from which card because
You don't need to worry about it.
yeah, we don't care. Just care
Yes.
about this is 84. Our
Actually, no need to
configuration will
worry
find
about
out.
it. The most important is the what do you say? The most important is the name. You create the name first. That is most important. The tagging.
Which is the IW.
Now IW64 is what? Which AI? AI1, AI2,
You
AI3.
need in the PLC tab.
Yes.
Start the project.
Yes.
Start with
TT1,
configure the PLC tab
TT2,
first.
TT3. Yes, that's what we do first.
Oh,
Then you won't get confused.
okay, and then we assign the. Okay, so this table is super important here. And this address is from the configuration.
Yeah. Okay.
Okay.
You give all the names, then only you won't be confused.
Okay, yeah. Okay. Normally you do do you come across you have to use a cable schedule?
Cable?
Cable schedule. Or I mean just when you do a project, do you have to use a cable schedule or actually or IO list or IO list?
Yeah, I always.
who is the one generate the IO list? Automation engineer or not automation engineer also?
Electrical.
Electrical.
Design the wiring diagram. From there only I know I will get the IO list. So good output going to be connected to the PLC.
The IO list contain the addresses.
Yes, of course.
Contain the addresses.
Address and the tag name.
So the guy who do the design at the beginning, he already tell you that I already define everything already. Let's say this is a list of whatever number of transmitter, and this transmitter is this range, this whatever, and even I define to you, this has to be go to this IO card, this port here.
Yes.
And then programming only, I follow. Because you tell me this IO card, this port, in my program, I will call it. This is, I will configure it.
Yes.
This way. And the configuration number is, you not create by yourself, the configuration number is, cannot give. But he just tell you the port only. But
Yeah,
he don't
then
tell you
once
that
then from
you
there
want
you
the
can.
MD 64 or you want the MD 80.
Yes. Then later on, once you done, you give this the addresses you selected. You give to him. He will update in the wiring diagram.
Okay. Then after you do the programming,
Yes.
you give all the addresses.
Only after. Once you do the configuration enough.
Or after you do the configuration, you give it back to the
Yes.
electrical guy.
Mm.
And he update all the wiring diagram, all
The numbers.
the numbers.
The number only. The port and the port and which terminal, everything is same. Just the address only.
Just the address only, which is
Follow
you can
this.
always change the content
Yes,
inside.
because it's a changeable here, right? So
Yes.
I change here, then I will update here. So he will update in the wiring diagram. Whether it's starting with I0.0 or 10.0.
Okay,
It depends on the program.
okay, got it. Okay, yeah.
Okay, good.
Yes.
Okay, go for break. Let the break we continue.
Okay. How we do the scaling is AI, right? Getting a integer, convert it to real. When we do AO, it's a reverse thing.
Yes,
Take a real,
convert to in.
scale 2 times, go auto,
Yes.
become a integer to go out.
Yes.
And the integer has to follow the manual again.
But it's the same value.
Oh,
27.
if your AI is a 0 to 10, what is this number? Your AO naturally follow the same.
Same number.
0 to 10 is
0
to 27.
0 to 10 or 4 to 20 is that. This 0 to 27,000 is the same thing.
Got your point. Okay, clear. Yeah. Okay.
Trying what?
Yeah.
You online, no, right?
You want to do this? Okay.
No, you the order of project. First one, add the analog output card.
Okay. Original 1200 do not have any AO.
You add 1215, 1217 F.
Okay, different model has different
Yes,
IO.
1211, 1212, 1214. It's three model you have.
Okay, yeah.
Yeah.
Okay.
Then okay. So this one is just power up.
Needs to power up using.
LNM.
Okay, okay.
24/0. So here very far. You need this 20. This LNM you can use also.
Okay, okay. Just wire.
Yes.
Okay.
So once done, so later on when we do something, we can just measure first up.
Okay, to check the.
Yes.
Okay, okay. This is a out 24 VDC, right?
Yes.
Oh, very stiff.
Yeah, maybe that one because that what we never used before. Very nice.
This is M to M. Okay, correct already. Yeah.
On. Second one. Yeah.
Second one.
Yes.
Okay.
Okay. That's why blinking, because you have, so what you do,
Have a configure.
yes, you add this module, then download the configuration. So you go to device, no, not add that,
Oh,
device configuration. You double click it. Open the PLC. Yes, here you add. On the hardware catalog, on the side. Yes.
okay.
This one is a EQ.
It is not from I search it and detect what is connected there, but okay.
EQ.
AQ.
Yes. 4. EQ 4. 500, you can see. 4 HD 32.
For HD.
Yes. Then once done, can you try to do programming scaling?
Can do.
Okay, try and see. Then later on,
Okay, now I enroll already.
okay, what is the address? Yes, you can use the property. Go to IOTEX, yes. 96, 98, all that. Then in the general, go to the AQ4, analog inputs. Oh no, let me check.
Oh, okay.
No, analog inputs. Okay, check. Channel 0. Okay, you can choose voltage or milliamp.
Okay, here I should remember to configure.
Yes.
So assuming we are
Using voltage, voltage like easy to
okay, this is
measure.
voltage.
Measure.
Okay, yeah. So here is fixed.
Mm.
Yes, I use voltage because always 0 to 10.
Yeah.
Okay, got it.
Then you got the address ready, right? QW96, right?
Yes.
Yes. Then now I can do.
We are going to connect
No, not going to connect anything. We just want to measure only.
okay, just want to measure.
So what you do, because scaling.
This is an AO here. Okay,
AO.
okay.
So analog output, how to scale? Analog input, we take the input, we convert into a unit, like temperature, pressure, like that. For analog output is the unit convert to analog value.
Okay, okay, yes.
So the unit is, you decide what unit you want to use. Like motor 0 to 50 Hertz or 0 to 100%.
Yes.
Ah.
Okay.
You try and see.
So now I have a 96.
Hmm.
100. Yeah, 102 again. You mean I create a block that is a reversing, right?
Yes. You want to use the normal Normax KX also can. You want to do a reversing FB also can.
There is no direct scaling, reverse scaling, is it?
No. You need to use the same thing. Normal X scale X.
No X first, then scale X second.
Yes, yes.
Oh, okay.
Same
okay.
thing. Only Y axis, X axis is different.
Okay, okay. Okay. Okay.
Okay.
You want to turn on the screen?
Yes.
So what?
No. Yours is you're almost there, but here don't fix the value.
Okay, I use
A variable.
from here.
Not only from normally a variable means a memory where you can key in from the HMI or from the program, or you want to use this MD4 also can, because it's a 0 to 16, right? Yeah, you can use the MD4 also can.
Okay. So it's an MD4 come from here. Here
Yeah.
is 0 to 16.
Yes.
Here is 0 to 16. And then the expectation here is 0 to 10 volt here. So whatever we see here, we measure is the same
Yes, correct.
voltage. Okay. So I download it.
Yes, of course, download. But did you download the configuration or not?
touch today, but maybe we will go today, right? It is how to say, how to retrieve the information from an external device that is not considered attached to this one. I say for instance, let's say we use a closest example is we use a Modbus of VFD.
Okay.
Because this Modbus of VFD, it could be is connect to the switch, and then the switch is directly come to a PLC, right?
Yes.
Could it be working also? Let's say this PLC has one Ethernet on it. It report to a higher switch,
Okay.
and the higher switch has other PLC also, has a VFD also.
Okay.
The VFD is connected to this switch here. It's not directly connected here.
Okay.
But this switch still can communicate with this VFD and give it command, start, stop, set point, can also.
Yes.
So just now, because just now, like, let's say we do the add the module, we attach it, then we directly add the model and everything, right?
Okay. Okay.
Let's say this is an external device. It could be an external VFD,
Okay.
could be like from other vendor stuff,
Okay.
just like we say, our meter, or could be a BMS module outside.
Okay.
It could be a brand of another PLC.
Okay. Any
outside.
device.
Yeah, any device outside.
Okay.
How do they communicate? Like,
How?
can they communicate just
Can.
doing this only? And then I can directly, like, let's say, assign some I and O, I and Q, pull the data from there to here, or export the value, go outside through the Modbus.
It depends on how you want to control a device. Okay?
Okay.
Okay. So let's say we talk about VFD first.
Okay, just VFD first.
Just VFD, because VFD can be wiring, can be communication, all that. Okay?
And the networking architecture doesn't matter.
Yeah.
From the top or from the bottom, doesn't matter.
Doesn't matter.
Doesn't matter.
Okay, now let's say we are using a PLC. Okay, so we have a VFD. Okay, let's say we just connect from the PLC,
Okay.
digital output to
Which is
on and off.
Just a on and off. Okay.
On and off.
Okay.
So the PLC can on off. I mean run stop lah. I put run stop. Run stop. Okay, so just no need to do any configuration.
No need.
Here you set the speed.
Okay. Okay.
Okay. Second one is this one apply for any device also. Same concept.
Okay.
DO, here is the AIAO. Means here run, stop, and also the speed is here.
Right. Still using wire lah. This one.
Still using wire lah. Okay?
Okay.
So you no need to do any configuration.
No need to do it because just have to configure the I/O.
Just have to configure the analog I/O like this lah. Like
Yes.
this,
Yes.
this setting now. Okay.
Yes.
Now, if I do PLC and VFD, okay. Now I do communication.
Okay. This is called communication.
Communication.
Okay. This is not common. Directly using wire is more common.
More common lah, depend lah, depend. So the PLC can control run, stop, speed, even can get some data like the motor temperature, the torque value,
Right.
all that. Okay, means so many data you can get from the VFD.
Okay.
Now, in this case, there's a two type. One is using Profinet or Profibus. because we're talking about Siemens, right?
Okay, yeah.
Profinet, Profibus, you must do configuration.
Through TIA portal,
Yes.
find the model.
Through TI portal, find the model. If another brand, you go to the website, download the Profibus, Profinet, the GST file,
Okay,
Install
GST
here.
file. Install,
then you can find
it.
Yes.
Then configure it as I configure the AO card here.
Yes. Then download the configuration.
Now the configuration. From there, then we will see
You will get the address.
address, a new list of address.
New address, then that address you use to run, stop, split, all that.
Okay, so you have a new list of AIAO,
AIAO.
AIDO,
Yes.
and just have to assign the address, read the manual.
Yes.
This
read the
AI
manual.
means this is run, this
Correct.
is stop. That's it, as simple as that.
Yes. Okay.
Okay,
Same thing for Modbus. If you're doing Modbus, this one you can do configuration, but you need to do Modbus programming.
okay. If the easiest is Profinet plus configuration, you
Yes.
can find the GSD.
Yes.
But not every vendor have a compatibility to the
Yes.
PLC.
Not every brand have Profinet.
Okay,
Some brand have Profinet, some brand don't have.
some brand not have. Then let's go to the most
Modbus.
Modbus, which is you have to do a lot of programming.
Yes, programming, the Modbus programming.
Okay.
So, there's a block.
okay.
So you see the Modbus block, right?
Yeah.
Take the block, you do the settings, everything. From there, you will get some integers. Similar concept. Similarly, you can read this, all this.
But let's say, okay, I think 1, 2, 3, I quite clear with what you say.
Yes.
Now, the last one, Modbus, which can happen frequently.
Yes.
Are we going to touch this Modbus? Can we try to touch one to see how the Modbus works?
Yes, I can.
Is it going to take a very long time, this one?
No, no.
Okay.
Just because for you can, no problem. But I don't have device, but what I do, I can do PLC to PLC Modbus data exchange.
Yeah,
So easy to understand.
because this is very
Because
important.
you
for
just
me,
need to know how to do the Modbus programming.
Right, how
Yeah.
the Modbus send a signal and retrieve a signal
Yes.
with a PLC.
Yes, yes. You
Okay.
can do PLC to PLC. Because the problem is, I have two drives support Modbus, but both are RTU, which is
Okay.
RS485. My PLC is TCP.
Or you cannot support RS-45.
RS485. So I need to buy the small.
But actually, there is a possibility to do this, right? For example, any VFD here, you connect to here. Even though we know that you have a GSD, but you don't choose the
GSD.
Yeah,
You
don't
choose
choose the
Modbus.
and yeah, change the
Can.
can also like for example connect to that, but I use a Modbus protocol. Yeah, then also I mean okay, just to see how the communication works.
Yes.
Yeah. I ask because definitely
Yeah, definitely. It's not
definitely
very
this is
common.
always same problem.
Very
Yeah.
common.
Yeah.
Yeah, because with Profibus, we talking about Siemens. Let's say
Right.
other brand.
Sorry?
Let's say other brands.
Okay.
Because like
Yeah.
Mitsubishi, they have CC link.
Right, right.
So only can support like Mitsubishi drive and some other drive, very limited drive that support CC link. Not all the drives support CC link.
And I haven't seen, but definitely I expect that it will common is PLC communicate to BMS. How does it work? Yeah.
Modbus.
Yeah, so it definitely go through Modbus, and the question is
Yes.
how they send the signal and
Can
control
very
each other.
very not can't say easy but straightforward.
Oh, not easy but straightforward.
Not easy but straightforward. If you understand the concept, you can catch it. I think you can get it. I don't have the device, but PLC to PLC we can do that.
Okay, 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 got
So
it.
means from that PLC, that data.
Okay,
This PLC.
okay, got it.
Or HMI. I can use Omron HMI using Modbus to communicate. Was okay.
Okay, yeah, yeah.
But before that, you have these 5 days, you just go and see what is Modbus first.
Okay.
Because Modbus, they have their own addressing.
Okay, I really don't know. I have to find out.
Yeah.
Find
Then
out.
no need
I
very
really don't know.
simple. Just go to YouTube, just see what is Modbus.
Okay.
Try to understand the Modbus, the concept first, because since it is not part of the configuration.
Okay.
So how do you have to communicate? It's very simple example I give you. My language is Tamil, your language is Chinese.
Okay.
Right? But I cannot understand your language, you cannot understand my language. But we are communicating in English,
Right.
which is common language.
Right.
So I convert my language to Tamil, from Tamil to English, then I send to you. Then what you do? From English you convert to Chinese, you understand. Same concept.
So both doing some conversion.
Some conversion. In this case means,
No
no
conversion.
conversion. I learn Chinese, then I talk to you.
Yes.
Something like that.
Yes.
Because I'm a different brand.
Right.
So, but I can learn, because it's like a GSD file, right? I can learn Chinese, then I can talk to your language.
Right.
Something like that.
Okay. Yeah.
So if I talk in the English, so English have different type of alphabets. There is an example.
Okay.
Different type of alphabets. So same concept. So they have their own addressing. So when you want to communicate, you have to use their own address.
When you say addressing is the
Addressing means like I, Q, M, D, B.
format of the variable.
Yes.
They have their own format of this.
Data type is still same. Word, Boolean, everything is still same. But the format, the address they use, it's not like I0.0. They very simple example. Okay, they what they have is they have like read coil, write coil, read register, write register is main form. So read coil means input, write coil means output. Read register is a analog input, write register is analog.
I get your point. In the industrial setting, most common, considered universal,
It's Modbus.
is Modbus.
Yes.
Whatever two devices cannot communicate,
I cannot communicate, I use Modbus.
use Modbus.
Yes.
That solves the problem.
Yes.
And Modbus can be connected through Ethernet.
Ethernet and also the RS for it.
Okay. Clear. Okay. So this is a action.
No. Start the movie.
Okay, so the function, the program is already done. I do a monitoring. So we have a 0 to 16 here, which is if I go to 5 now, here is reading 8, and then by right here I should read 8 as well. And here, convert back to 0.5, 0.5, come up here, is half of 26,000.
You measure,
So,
you go to voltage and measure.
this is the DC.
Yeah, choose DC.
Okay. You want to see through correctly, so
Okay, so you use what? QW96, right? QW96 means which one? Oh, our output is down here. Okay. So it's 0M and 0. This is the AO cut, right? AO cut.
okay, so now I use
96.
96.
96 is the first one.
96 is the first one.
Yes. So 0M, 0.
0 and 0. Okay.
No, this one wrong. This one must be DC.
This one and this one.
Yes, correct.
Which is on top.
Yes, correct.
Is the first one and second one?
No,
No.
because got the three dot after the three dots.
What is the three dot mean?
Because why? Because they use the same casing.
Oh,
Ah.
okay, so it's actually
Not in use.
not in use lah. Okay, 1, 2, 3 is missing.
Mm.
So it's a 4 and 5.
Yes, correct.
4 and 5.
You should get what?
I should keep a 5 volt here.
Yes.
Okay, so this is 5 volt, so everything works.
Then I increase, you just put it.
Okay, 4 and 5.
You hold. Okay, wait. You take it first. Maybe the screw is loose. Sometimes it's like that. Okay.
4.
Because no wiring there. Yes, 5 or 6. Then I put to 8.
Ah, okay, it works.
Works.
Nice.
Yes.
Okay.
I think I'm not exaggerating. I think you are the only one. I never teach the output doing yourself.
Because you say already same concept.
No, because you already understand the concept.
Right, yeah.
Because you know, input I need to convert to something, a unit. Then for the output, you must put the unit. Then you need to convert.
Right.
Correct.
But my
So sometimes they confuse.
Yeah.
Because you know why you can do this, because you see a lot of analog inputs,
Right,
analog
because my work
outputs,
is
you
doing a
do
lot
that
of
lot
this.
of that.
Yes.
So you already know what is input, what is output,
Yeah.
how the input work, how the output work. Yes.
I know it from the.
Because you know already.
Yes.
Right? You mean you
Yes.
know in the instrument side, you know how it works, everything.
Yes.
So
I
that's
don't
why
know the
you,
programming side.
that's why you can easily crack it and do it.
Yeah.
Sometimes they know analog. That's why I say. Because sometimes the people what they notice, they scared. Analog means difficult programming. Difficult to do programming. Even myself also say, when I start to do, very difficult how to do a program. Once you understand concept, it's very straightforward. You just need to know the concept. Why we doing scaling? That's the main thing.
Yes.
Ah.
Yes.
Why we doing scaling? Because without I do scale, can I do program or not? Can. But I must use the 0 to 27,000. I must do program using this value. Right? I still can do program, no problem. But can I show in the HMI? Cannot. Can
Very
someone?
user friendly.
Yes.
Yeah.
So can I show in the HMI the value? Cannot. Okay. Can I? If other people with less knowledge on analog, can they go and troubleshoot? Cannot.
Right.
So that is the reason we do scale.
I got your point.
Mhm.
Yeah. Yeah. The most I deal with is analog actually.
Yeah.
Yeah.
That's why very fast catch it.
Right.
But this one now we just because we don't have any project yet. That's why we just directly convert, directly take this one, right? If we have a project, then this one we can do like a set point. You manually in the HMI can key in.
Actually, just now when you were going out, I was trying to do some set point
Okay.
thing, yeah, to see whether it works or not.
Is it working?
Haven't tried. Haven't tried. Yeah. So probably just about a test. But essentially, I created a block with additional.
Okay, you see the block. I want to see how the block look.
This is a.
Hey, you can open the block. No, not TV.
Ah.
The FB.
Right.
Okay, go down. Monitor. Okay, so it's
This is
go
a
down.
transfer. This is a scaling.
Okay, high action, low action.
Right. So essentially,
Low set point.
yeah, somebody
High set
key
point.
the correct set point.
Okay, you put
Then
okay,
it
set,
triggers the
set.
action, which is the lamp here.
Okay.
Then I'm not sure if I have done reset. Reset is outside the. Yeah, reset is outside the.
No, cannot. This set you can put outside.
Huh?
This set you
Oh,
must.
because it's inside here.
because it's resetting inside here.
Because low action and high action is a local.
Yes, you must reset this, not the outside the block. I know what you mean. You go back to here.
Because I was thinking, let's say a project, you have on this panel, you have a 20 alarm lamp, and then you only have one button to reset, right?
Yeah, of course.
Then you press one time, then 20 will go off.
Yeah, you don't worry. That one we will learn. We will do SCADA and alarm. At that time I show you how to put one button to what to
Clear all the
clear all the
alarm.
alarm. Yes.
Yeah, but actually on this one, because the low action and high action is in the
Block.
I must do the reset here.
Yes, in the block.
Okay. Now I know. Okay. Unless I have to refresh it, or otherwise I have to create a new refresh button here.
You have a reset button?
I have a.
Okay. Okay, wait. Good. You go back to the main. Do you have the reset outside?
Okay, I have a reset outside.
Okay.
Yeah.
This is a reset, right?
Yes.
You delete this.
Okay, delete.
Delete. Okay. Now, go inside.
Temperature. Okay.
No, the FB. You use the reset. You don't need to create a local input. You can straight away use the PLC tab.
Which is a Q.
The I.
The I. Yeah, the I.
Yes. I 0.0. Because you wanted to use the first button, right?
Yes.
Okay.
Okay. So
You know why I tell you can use this one, because even though this block multiple time I want to use, the reset button is the same button.
Oh, it's a global.
It's a global, so I straight away use the global here.
Okay.
Because-
I don't have to put outside actually.
Yes, because the high action, low action, for each one will have a different addresses,
Right.
different labs, right?
Yes. Okay, so this is a global, even though it's inside block, it still will respond to it.
Yes,
So I
of
don't have
course.
to define anything.
Yes.
So okay, low action, high action, save it, download it, where so now off is triggered. Interesting. It is not resetting. Oh,
What resetting? Because
because the scale here, this is not following our 8 to 16 lah, I think.
oh, okay.
Yeah, because here I haven't do everything here. Min max, all the stuff here.
No.
This is
that
the
one's
old
okay.
one. Yeah.
No, go down. It's still correct. Maybe your comparison is wrong.
Oh.
Because this one must be less than. Correct or not? If it is less than 10, it's a low action.
Right, but if I reset it already, I expect the low action to be 0, right?
Yeah.
So if let's say I trigger,
Yeah, you trigger that. But still, can you see this line is still on? Okay, what I mean
this
is,
is a high action.
no. What I mean is, okay, you go to these two, low action, high action. Okay, just let me know when you want to on the low action.
Let's say this is a 80, right? This is 80. I want to on the low action when it's below 10.
Yes, then it's less than. You must put less than, not greater than.
Oh, okay, reverse already.
Yes.
How about we choose a block?
No, you can double click here, change.
Oh, okay.
You can double click on top, yeah. Supposed to be less than, yes. This one greater than. That's why I say, because when your value is 70, it's suppose both are not on. Right or not?
Right. Well, you don't have to go to all the scale, just read the scale here. You read the value here, you know already.
Yeah.
Set it first. Even though now I have downloaded the program, I haven't do anything. The step we already changed here. The lamp is directly on already
Yeah.
because because of the data block.
Earlier.
Data block.
Yes.
So
Earlier values.
earlier value is we leave it one here.
Mm.
So I expect I push a button here, clear everything.
Yes.
Okay.
So when next time.
That's right. Okay, it's triggered.
Yes.
Okay, yeah. Interesting. Okay, yeah.
PLC. When you, because the advantage you have is you already work on this.
Seen the
You know,
beauty.
you've seen everything, but you don't know how the PLC works.
Right, I've seen everything outside, but I don't know how
How
inside
it
the black
works.
box.
So when we do one by one, then you can relate it. Okay, now you can. Okay, this is how it works. This is how it works.
Right.
Okay. Any question until the 3 days? How you feel?
Everything is new. Everything is good for me.
Okay.
Everything is good for me. Yeah. It's only like just like I say. Definitely like I say, because I try to close the gap. What is I don't know, right? I know a part of it of the whole project
Yes.
This is a part that totally for me is a covered area. I don't know what is happening inside here.
Yes.
I try to explore, to close all the gaps so that I know this piece is actually how it
How
works.
it works, yes.
Yeah.
Because then only if you have any problem during the commissioning time, so
Then
you
I
know who to.
Yeah, who to talk to.
Yes.
Why this is his problem, not his problem,
Yes.
and so on.
Yes, correct.
Yeah.
So because you see, you have a PLC guy and also instrumentation guy. So when you see something problem with the value,
Yeah.
So,
as simple as that.
you
Yeah.
so what do you do? Okay, first you call the instrument guy to check,
Right.
because PLC no value. It's supposed to have value. So you check, you inject the value.
Yeah.
Auto 20 you inject. You see here don't have. Okay, you check. Then you call the wiring guy to check whether the 420 they inject from the instrument until this device here input here you can get 420 or not.
Right.
Once you get 420 but still no value in your SCADA, then you call the PLC guy.
Yeah. It's like things like this lah.
Yes.
Yeah.
So
And then
you
a
know-
lot of things are a lot of
Yes,
time.
you know, because
Yeah.
if let's say if you don't know this, don't know about PLC, okay, how the PLC works, for example, so if you have the same problem, in the SCADA don't have value, what you will think? Okay, SCADA problem. So you will call the SCADA guy. SCADA guy come and tell, my side is okay. Call the instrumentation guy. So you do the other way.
And or they would just say that
This guy, because
this
I
working
mine is
problem.
okay, yours is
Yeah.
yours. So
Yeah.
when you know how these things works, because you know how the instrument works, now you don't know how the PLC SCADA works, right? So
Right.
now you know how it works. So now you know, so you can decide who to engage with.
Right. And even better is how to plan the work.
Yes,
Before we start,
yes,
make sure you check everything first.
Yes.
Show a record of what record you want to
yes,
see.
correct.
Yeah.
Yes, correct. So it's okay, let's say if I can give suggestion, okay, once they're done everything, because PLC is the final part.
Right.
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 The final part is the PLC. Before that, the wiring and things. So now you can do the what instrumentation check. Okay, 420. Okay, when you inject 420 here, you can get 420 or not, or the terminal block here.
As simple as this, even I go to the field before, I see the lamp, I also cannot tell what does it mean here.
Yes.
Yeah.
Because it shows the lamp is on.
Right. So
It's okay.
right, yeah, or which point I have to check
Yes.
the
Even when PLC no program, no problem.
actually a lot of things can be checked. Yeah.
Yes. Even no program, no problem. You just connect You just create a new project, no need the hardware, everything.
Try to
Just choose
force
the
it
PLC,
together,
no
right?
need to force also. Like for example, you want to check whether the temperature value is in or not. The analog value is in or not.
Right,
Okay,
right.
for example,
On the PLC first.
on the PLC, just open a new project, configure the PLC, no need the hardware, no problem.
Right.
Okay, need hardware, no problem. Just connect, just key in IW. If it is this one lah. If it is they inject here, then you do the configuration. You do the full configuration. The addressing doesn't matter.
You see, there's a part here. The configuration actually can solve a lot of problem already.
Yes.
Before the program go in, configuration, I think at least all the DIT all can be checked already.
Yes.
But that goes to the next problem. The AIAO, all this cannot be checked.
Okay.
But because you don't have a scaling problem, you don't have a
No
scaling.
need scaling.
Yeah.
That's why I say no need scaling. Okay, what you can do, you configure the whole thing, everything.
Right.
Okay. The addressing, maybe you can, if the in the wiring diagram they already add all the addresses,
Right.
you can put the addresses here according to address. Just now it's 96 to 684 something, right? Okay. Maybe in the wiring diagram it's not 96. They already changed to 100, for example.
Right.
Okay.
Right.
So you, according to wiring diagram, you will prepare the configuration, download the hardware configuration, just open up your watch table, you key all the analogs, all the digitals.
But the first thing is you have to download the correct
Correct configuration, correct address.
So this is checking the configuration first.
Yes.
And checking the configuration, what you receive is your integer lah.
Yes, the 27,000.
Okay.
Not the temperature, not the pressure, the 27,000.
At least can check up to this point.
Yes.
See the integer is working or not.
Integer working or not? Because if let's say integer is working, after the programmer come and download, you cannot see in the HMI, right? The value is wrong. So you can tell that the programmer, because I already checked all the integers is working.
I know what you're saying.
Yes.
But I say that this is depend on project to project.
Yeah, of course lah, project to project.
Because the most important part is depend on the project, how to demarcate who to do what.
Yes.
My last project, we go into a very, very problematic issue because of in the early of the tendering, a mistake was made up. When during the tendering, the instrument supplier and the automation team is a different contractor.
Oh, okay.
So this guy buy the instrument,
This guy
This
do
guy-
the configurations.
not even do the configuration. This guy supply the hardware of the equipment.
Okay,
The
PLCs.
PLC, everything. And then there is a lot of gray area, who do the termination, who supply the wire, all this a lot of problem. Then automation software and another party again. So three different party
Involved in the project.
involved in one, not simple lah, because the scope is too big. Already.
Okay, understand.
Then a lot of mistake, a lot of engineering interfaces,
Yes.
and a lot of this guy he haven't checked this, and this guy not receive it, and this guy say it's wrong, this guy say another person do programming is wrong,
Yes.
because there is no proof who to check, how to check.
Yes.
If just a small thing like somebody changed from the IO originally like, oh I buy this instrument originally this spec and buy another spec. It could cause a lot of people on the field, on the programming to change to make everything correct.
Yes, even a simple example.
Yeah, just
I
a
give
small
you.
thing change.
Just a
Yeah.
small thing change. I give you example now. Let's say
Yeah.
my instrument is 4 to 20 milliamp,
Right.
but the setting here I put 0 to 20 milliamp. Okay, and I scale for 0 to 20 milliamp. Right?
Right.
You won't get the correct value.
Yes.
It's supposed to be pressure, supposed to be 5 bar, but here you only get like 3.5 bar.
It goes to the point of what is the condition of handle, how to handle properly. If this guy you are doing instrumentation on it, do you include termination or no termination?
Yes.
If you do termination, then what kind of proof you have to prove that your termination is all correct? right?
Yes.
If you have not do termination, who do it? And before he hand over to the automation team to install to download the PLC,
Download the PLC,
he have
print
how
the
to
panel.
prove, yeah.
The wiring team is most important if you ask me.
That is where you miss out.
Yes.
Very stupid in the very stupid early alignment.
Yeah, because
Somebody say a stupid
those
thing
who
of
design the wiring diagram
right.
is actually the most important kind.
That's where I ask a lot of wiring questions because I get the most problem from the wiring itself.
Yes, because
Yeah. Somebody make a decision in the very beginning, during the bidding. Whoever supply the instrument, do the termination of the instrument side.
yes,
Whoever supply the PLC or the RIO panel or whatever, do the termination on his side. So he work in the silo, he terminate whatever he like. He work in the silo, he terminate whatever he like. And the project is rushing, right?
Yes.
Every project is so rushing. Oh, I have
Of
no
course.
time, I have no time. So they terminate all wrongly, and they terminate all wrongly, and then when you do look check, everything is wrong. You ask him, then he say he's wrong, I'm correct. You ask him, then he say he's wrong, I'm correct. And the handover becomes so messy.
yeah,
So this is the kind of lesson learned. This is the kind of lesson learned.
yeah.
If from the very beginning, should never break the automation or the whole control scope
Yes,
into so many small contractors.
yes,
One
yes.
whole thing should be under one contractor only.
One contractor, okay, for example, you ask me to do the PLC, the panel, and the instrumentation. You give it to me, for example. Then I hire a programmer.
Yeah, you
Yes.
do it by yourself.
Yeah.
But the
Not
contact
you.
point is one person.
Yes. So
Yeah.
why? Because if you give me the project, the three projects,
Yes.
all the three, so I will be responsible.
Yes, you're
For that
responsible.
work.
You say it's not working, you cannot blame that or I or him or whatever.
Yes.
You have to fix it with your subcon.
Yes.
But yeah, this is the lesson learned anyway. Yeah. Okay. Yeah. Very very good.
Okay, you close everything, then you can save your the folder.
Oh, okay. So I copy the manual first.
Is this C?
No, no type C.
Okay.
Never mind. Never mind.
You want C to USB?
You have a C to USB. If you have, then I can.
Oh no. Wait.
So I think I'm coming back next week, right? We meet up next week,
Friday. Saturday.
Saturday. We going to go through the VFD
Yes.
and
Because analog doesn't cover already,
okay.
so we can back up the analog. So we will be doing VFD, of course the PID,
PID
and Modbus,
and Modbus
SCADA.
and SCADA.
Yes. In the SCADA we will learn
trending.
trending and alarm.
Okay. Okay.
So when we do that, we will be doing DB,
DB.
the global DB,
Okay.
because we haven't done the global DB yet. Correct or not?
Yes. One more question.
Yes.
The user level. Is it the user level is part of the feature of a SCADA?
The user
Or no,
level.
HMI also have the user level.
Yes, yes, yes. But I don't teach that.
I mean,
This
maybe.
is part of the SCADA.
right?
Oh, thank you.
No,
Thanks a lot. Thanks a lot.
we are used to. Because nowadays all the external hard disk costs started to become smaller.
Wow, you're very organized. It's just a small thing. I'm just wondering like how complicated is this or how.
No, it's just a user you need to do the user administration settings there. So in the settings, so you need to create a few users, then you must make it like level, which level, after that.
And you can control, but this is definitely it's a SCADA or HMI thing. It's not a PLC thing.
No, it's not a PLC thing. It's the setting in the SCADA and the HMI.
Okay. you.
Okay, boss.
Thank you, boss. Okay, done.
Yes. When you can delete it, mine. I just going to
How much? Or do you guys have I just wondered, do you guys have a second hand
the 1002.
1002? Like for me, if I can get one,
I will check for you.
yeah, like the 1002 would have an AIA or DIDO also, right?
Yeah. AI only. It's 1215 that is AIA only.
1215, which is more expensive.
Yeah.
But okay, yeah,
I will check
just
for you.
wondering anyone selling second hand
Yeah, I will check.
in the market. Yeah.
Because last time, normally we buy one company there. So last time they have 1215. Then the previous one of my participant he request for that.
Oh,
then
he also request.
Then I checked with him. Then he finished already. He already sold out. Then I checked again. 1212 they have. 1215 I checked.
Okay.
Then I update you.
Alright, thank you.
Yes. No, yours I just leave it here again. Next week, come and continue.
Oh yeah, like
Because Monday to Friday I have only one tax Omron, so I can put it.
okay.
So this one only the discount.
Okay then. Alright.
Okay, boss.
Yeah.
See you next week. See you. Can use this?
That is fine.
So use that cable.
Bye. See you next week.
Okay, sir. See you next week then. Yeah. Thank you. Power supply. Got it. New printer.
Yeah. You remind me the name, tomorrow one?
Yeah, what's his name? Check and see. What's his name?
Low give me a second.
Low. No, actual பேர் மாத்துறேன்.
low gain sweep.
LO.
LOH.
LOH.
GIN.
LOH. Yeah, he's a Tamanyu guy, right? Wait. Why this one not working? Oh. What happened to this WhatsApp? Can log everything now, bro?